I welcome all the speakers and panel members. And beside that, we are expecting few more panel members, Mr. Naresh, Ms. Madhurima Madhav, Ms. Dolarai Sautri, Mr. Vairagi LNT. I welcome all the panelists and speakers for the very, very exciting second event of IGC 2021, that is the so-called pre-conference workshop on geotechnical practices, academia and industry perspective. I welcome my co-coordinators, Professor Suresh and Dr. Kumar Pichumani. In fact, we discussed a lot to bring out, connecting people is not so easy, and especially connecting industry and academia is not very easy task. So when this IGC 2021 has awarded to IGS Trichy chapter, this is what struck in my mind, the very first event to have such kind of interaction. So we have excellent, very eminent academicians and leading practitioners in this pre-conference workshop. I'm sure that this pre-conference workshop will be an enlightening event, and it will be a small spark we are creating, and this will be carried forward for many other occasions to have such kind of events. So once again, I welcome all the members. I welcome Professor Samathia, President IGS, all the executive committee members, all the participants for having considered this program as one of important event in IGS 2021. I'm sure that you will enrich your, you may have a lot of unsolved questions or unanswered questions. So this is the right platform. You can throw all your unsolved questions or unsolved problems during the time of panel's discussion. We will come out some sort of very good documentation towards the end, and this will be taken forward with the help of IGS. We will carry this further and we'll formulate certain kind of guidelines for industry academia interaction. So with that, once again, I welcome all the members for this particular event. Thank you all. So over to Dr. Sridhi. Srish, please.
Yeah, thank you, Professor Muthukumaran, for your welcome address. And I request Professor Samathia, the President IGS and Professor of IIT Roorkee, to give a inaugural address.
A very good afternoon to all of you. Professor Raju, Dr. Ramakrishna, and all other dignitaries, panelists, and delegates present here. With a boom in infrastructural projects in the country, many advancements and improvement in the design and construction practices are taking place. In order to complement the process, we need good quality research by the academia. From a scholastic perspective, there has been notable advancement in the theoretical aspects of geotechnical engineering. However, academia is sometimes too academic for industry or does not fully understand what industry needs or wants. On the other hand, practitioners tend to rely on the transferable technologies and follow established developments that are best suited to the field applications and reluctant to try products from the research. The geotechnical engineering discipline has rightly been described as the scientific art, where a strong linkage between research and practice is imperative for its further advancement. Closing the gap between research and practice is always a great topic of discussion in the geotechnical field. Although it is not sometimes easy to apply new technology, and one of the possible reasons is that the new technology is completely new to the geotechnical engineers, field engineers. The engineers often don't have the time to understand the new theories and algorithms to see how they apply in their work. In addition, there might not be enough evidence or data to support the new technology. If there is no significant and immediate benefit, industry will tend to stick with usual practice. Researchers at times do not focus on meeting practitioners' need during research. This is understandable, as they may have their own research goals and they have to publish their research in journals, which are often not practically oriented. On the other hand, researchers may not have full control of the research topic. Researchers may have to compete for funding, and they have to propose topics that interest funding agencies. That is another reason. Therefore, it is not easy to bring research and practice together, as Professor Muthukumaran has said, under the same umbrella. But today, the organizers of IGC 2021 have tried to do so, and they have brought the practitioners and the researchers under one umbrella in this panel discussion. I'm very happy to be part of this pre-conference workshop entitled Geotechnical Engineering Practices, Academia and Industry Perspective, showcasing the activities of IGS and the relevance in field practice. I'm sure all the delegates will be highly benefited by the deliberations held during the workshop. I wish the workshop a grand success, and I thank the organizers for inviting me to be part of the workshop. Thank you so much.
Thank you, Professor Samaria, for your welcome address. Thank you for your time for this busy schedule. So next, probably we'll start with the keynote address, or inaugural address by Professor Raju, who doesn't need any formal introduction for this august audience that we have today. But for the benefit, we just introduce Professor Raju. So Professor Raju is ex-director IIT Delhi, and prior to that, he was a professor, dean, HOD, head of the department at IIT Madras, senior professor from IIT Department of Civil Engineering, and he has been commissioned for 42 plus years, and now currently he's a very active consultant, and he has been providing consultation for foundation designs for various infrastructure. So with this little background, I request Professor Raju to start his presentation. So over to Professor Raju.
Thank you very much, Sirish, distinguished colleagues, and my dear participants. I'm really delighted to be a part of this pre-conference workshop. You know, what I've been saying is that we've been trying very hard over the years, and then we have made progress also in bringing the academia and industry together. But as I pointed out by the president of our IGS, there are issues and concerns on both sides. And so I thought I will just focus on some practical aspects. And, you know, the saying is like this. As a teacher, we always used to say, if you're doing research, be as critical as you can. You know, because research is for what? When you do a PhD, you are not really discovering anything. You're only trying to learn how to be critical, how to be analytical, and how to analyze, how to summarize, how to present. Then when it comes to the practical aspects, you have to be as practical as you can. So, and then of course, we tried our best over the years, our generation, to improve the geotechnical practices in the country. We only partially succeeded, so a lot more needs to be done. That is on the shoulders of the present generation and the younger generation. So I'm very convinced that you will take it forward to international standards. So now I'll start with my PowerPoint presentation. Are you able to see the presentation?
Yes, sir.
Okay, good. See, this title I have given is Geotechnical Investigations, because that is the starting point for any practice. Challenges of quality. And after you do the investigation, the next step is interpretation of the data that you have. for optimum foundation designs. I will not go through every point to save time for discussions. I will only highlight some of these things. The preamble I wanted to say is this presentation is a token contribution to the national effort to achieve best international practices. No intention of commenting on anyone or belittling anybody. I try to compare here the geotechnical engineering practice globally, or I would call it best practice. And what is the present situation in India? I'll straight away go to point number 3. Preliminary geotechnical investigation by an accredited agency is the best practice. Why preliminary investigation? Unless you know broadly the strata conditions, you will not be able to plan the geotechnical investigation because planning is very important. Then I'll go to number 4, project layout, best practice, project layout with location of important structures made available to a geotechnical consultant. In this case, in Indian case, mostly it is the geotechnical investigation agency. Generally, these are not made available to the agency. That is the problem. Then what is the scope of detailed geotechnical investigations? Who decides this? So it is the geotechnical consultant, in consultation with the structural consultant or whoever are the planners of the project, he decides. But in India, it is not the common practice. Most often, a bill of quantities and a standard set of laboratory tests are given to the agency, maybe by the architect or the structural designer. This is inappropriate also because the laboratory tests are a function of the type of soil stream. For example, we know in Delhi, we have so much, or in the northern belt, we have hundreds of meters of thick of alluvium. So I've seen geotechnical investigation specifications saying, rock force, rock coring, rock strengths, things like that. That's what happens. Then point number 6, detailed soil investigation by an accredited and qualified investigation agency. And investigations done under independent supervision by a qualified person. So the supervision independent of the investigating agency. Lack of accreditation process, I think there is some progress now, but still there are many agencies which are not accredited. And accreditation itself is a challenge because there are not enough people who can go through the process of accreditation. Most investigation agencies are not accredited. They do not have trained manpower. Mostly not supervised. Point number 7 is investigation report by the agency giving the results of field and laboratory tests only. I want to underline this. Only field and laboratory test results are given. No foundation recommendations. Foundation recommendations is not in the scope of the agency, geotechnical investigations. In India, what happens? Results of field and laboratory tests are given. Recommendations or foundations are given. They are in fact demanded by the tender process. In the tender process, they will say you have to give the foundation. Safe bearing capacities and pile capacities without having full details of the structure. So they have no idea at all. I can give you any number of examples. With 4 basements, the founding level is 20 meters. The investigation agency gives the bearing capacity at 1.5. So it's totally meaningless. Then point number 8, best practice, interpretation of the results by a specialist foundation consultant. Unfortunately, we don't have enough of them in the country. And recommendation for type of foundation and foundation parameters. That is his job. That is not the case in India. Then point number 9 is interaction between foundation and structural consultant and finalization of foundation design. That is not the practice here. Number 10 is involvement of foundation consultant during execution, review of results of further tests, pile load tests, pile integrity tests, and so on and so forth. This is very rare in our country. 11, extremely important, settlement observations and information to foundation consultant. So feedback with foundation consultant. That doesn't happen here. Foundation performance assessment and report by foundation consultant. Never done here. I will only highlight one or two things from the Euro Code 7, which is a very nice code, well done. Some of our colleagues who are in the Indian standards preparation, they should take note of this. Point number 1 is data required for design are collected, recorded, and interpreted by appropriately qualified person. Then the various assumptions, and these assumptions need, point number 5, these assumptions need to be considered both by the designer and the client. To prevent uncertainty, compliance should be documented. Example in the geotechnical design. Euro Code 7 is a good code, so I really like it. Quality of investigation, I want to highlight that. High quality is the very basis for excellence in practice. Now, that is obvious. Then I'll go to the 4th point. Unfortunately, the majority of cases, the practice is nearer to the primitive. Many of the cases, what I see. Once again, I'm summarizing it. Some of you might have seen this presentation before because I'm hammering this point again and again, and with some limited success, but hopefully more success will come. Again, India, poor quality of the equipment, world standard, highly sophisticated equipment. We are even today doing wash boring, shell and auger, of course, wash boring. In the West, if it is required, they will even go for continuous core sampling, even in soil. Continuously all the soil strata is exposed. Manual operation of the SPD equipment. I'm really sick of this manual operation. So actually, wherever we are involved, we are making it mandatory. You have to use SPD equipment with automatic hammer release, trip hammers. Static cone penetration equipment with mechanical cone, which is so obsolete. Static cone with electric cone and piezo. I'm very delighted yesterday to receive a call from one of our leading agencies saying, he was very proudly mentioning, I don't want to mention the name of the company, that he has acquired a static cone with electric cone. So that means we are making progress. Look at the left. I feel like crying. What happens is when the report comes to us, with this type of investigating thing, you can see that. And then, I'll say this is not enough. This investigation, we cannot come to any conclusion. No, sir, we are very great in hurry. We cannot do anything more. And please, can you? It's terrible. This is 2021. Huh? Look at the left. SPD hammer. How can 4 people release the hammer simultaneously? Crazy. This is 2019. So I'm sure my guess is maybe 70% of the agencies in the country or 80% are using only this. Maybe hardly 10% are using trip hammers. Static cone, mechanical cone with all sorts of arrangements for the reaction. And then this is crawler mounted on the right. One more challenge I have come across with regard to water table measurement. Suddenly I'm finding all this strata is all clay. And suddenly the agency says the water table is at 1 meter below ground. How can we have a water table in clay? Now I found out most of the boreholes are done using bentonite slurry for stabilization of the slides. And as per the code, you have to take the water table measurement 12 to 24 hours after completion of the borehole. At the time of completion of the borehole, the slurry level will be at the top. In purely clayey soils, the slurry level in the borehole will not go down because it cannot penetrate into the ground. And then the agency thinks that is the water table. Even in coidonless soils, because of bentonite slurry, it forms a layer on the borehole walls, and the water table, the slurry level cannot go down. then he is over-reporting. In fact, in almost all the cases, we find that the water table is much lower than what is reported in the investigations. And this water table has a great influence in assessing the liquefaction potential of the stream. So we all end up coming to wrong conclusions because of the wrong water table. I just want to share one example, a recent one. Right now, we have completed our recommendation. The project in Arunachal Pradesh. You know, first field investigations were done by somebody, and then some laboratory tests. Then some other agencies did the laboratory tests again. Then the third agency did a repeat investigation. So you can look at this. This is the fines content that has been reported by different agencies. Just for an example, let me take the topmost value, 0.75 meter. One agency says it is 81%. The second agency says it is 16%, and third agency 38%. Look at this tremendous confusion. The next point, after we have done the investigations, how do we assess the soil parameters required? I'll take the example of alluvial soils or sandy strata, collisionless soils. In collisionless soils, there is no bearing capacity. If you have very high rise tower, 30 stories or 50 stories, you have a huge raft. The raft will never fail in bearing. Only settlements will fail. Okay. For assessing the settlements, you need the soil modulus or the soil stiffness. And then the only way we get this today is, of course, one is you can do pressure meter tests, which is very rare, except maybe very important projects. In one nuclear power plant in Haryana, we did a lot of pressure meter tests. But otherwise, it's only nothing else, SPT one, we have to depend on. And we know how much variation you have in SPT values, depending on whether you use auto trip hammer or what type of equipment you use and all that. So look at this figure. This is as per IS 8009, 1976, reaffirmed 1998. So if you go into this figure, for n is equal to 40, and where the overburden pressure is 0, that means at the surface, modulus is 800 kilograms per centimeter square. I'm a little old-fashioned, so I'm using still kilograms. Okay, that is one number. Again, for the same n is equal to 40, if the overburden pressure is 1.5 kilograms per centimeter square, the value is only 400. So how will it vary so much? And it's still a part of our code. The second one, 8009, reaffirmed 1998. You can read the settlements per unit pressure as a function of width of the foundation. Curve becomes asymptotic after a width of 3 to 4 meters. So that means even if you have a 40-50 meter raft, according to this graph, there will be no further increase in settlements. How is this possible? This cannot certainly be applied for bigger rafts. So we are sitting on codes, which are highly misleading. Of course, I was part of all these codes before, but so now the next generation has to take it over and then take it forward. The one correlation we use very frequently, I've been using it for the last 40, 50 years, is called Shul correlation, which correlates n value with soil modulus with the curve as shown. The most often people refer to balls, the standard foundation book by balls. It has become so popular, I don't know why. There is so much junk in that book, but still it is very popular. He gives so many equations for the same material. ES 500 n plus 15 and 7,000 n under root 6,000 n. Okay. And Japanese standard is more realistic. It gives a value of 2,600 to 2,900 n in kilopascals. But I tried very hard to source the Japanese standard. I am not able to get it. In fact, I used the office goodwill of my close classmate and friend Madhav, who was in Japan, and he has spent a lot of time there. But still, I don't have access to this code. If you have it, kindly share. There is a Syria report 143, which is also a very good report, and it also has got a relationship between soil modulus and N value. ES by N is 1 megapascals or 1000. Now comes. I've compared here. Please look at the top only. The rest of it you can read later. Let us say N is equal to 10. So as per IS, we get some values, 61,000, 22,000. Shul 29,000. Syria report 10,000. Then Japanese standard 26,000, 29,000. Bowls some, I'm not able to see the number here because of the picture, 12,500. Settlements are directly proportional to the soil modulus. Depending on which value you use, you get a variation of 3 times. No? So what do you do? How do you design when you get a variation of 3 times, depending on what you use? Shul's correlation is based on actual settlement observations in Germany. I know that. When I was a doctoral student in Germany in the 1960s, they used to it. But the sad part is I'm not able to get the original publication of this correlation. So I've written to my German friends and all, and they said that book is no more available and whatever it is. We have been using this correlation for more than 40 years. This is based on actual settlement observation. Large-scale footing load tests carried out at Terminal T3 of the Delhi airport have shown that the actual soil modulus values are 1.4 to 1.5 times higher. That means even this value, which is relatively high, that also is conservative. That's okay. At least it's not as conservative by a factor of 3 or 4. Okay. Settlement observations, a comparison between estimated and measured values. The estimates I am presenting here based on Shul's correlation. Delhi Airport Terminal T3, which is on raft. I have to share with you, I've said this before also, I have to share with you, the contract for Terminal T3 was given to L&T by GMR on the basis of a pile formation. Later, as I've been consulting to L&T for more than 40, 50 years, later L&T team and also myself have sat together and showed that no piles are required. There is not a single pile under Terminal T3, which enabled to speed up the project by 6 months. And think of it, if you get, first of all, the savings on the investment and then the benefits to Delhi and the nation, then you get the airport 6 months later. In Badurgar, S plus 14 floors, estimated settlements are between 67 and 75 mm. Actual settlement measurements 58 to 60. So that means we are still slightly overestimating. 51-story tower in Gurgaon. This is on a pile raft. It's not on raft, it's on pile raft. 50 mm is the estimated settlement. Actual settlement is only 25 mm. We did a 30-story building in Gurgaon on raft only. Estimated settlement 40 mm, actual settlement 35. In every soil investigation, every foundation recommendation report we give, we boldly write that settlement observations are a must. That is the only way you can improve your practice. There is no other way. There is no shortcut to this. So I feel that we should make, through the code also, settlement observation to be made mandatory in all important structures. There should be a requirement like that. This will enhance our capability to carry out optimum design of foundations. That's all I would like to say, and I hope we have a little time for discussion. I don't know. I leave it to the organizers. Otherwise, I encourage all of you to write a brief mail to me. I will definitely answer your mails if you have any queries. Only thing I cannot do is sometimes I get a request, sir, we want to learn the practice and we want to do the pile draft design. Can you guide us? So much time I don't have. And also guiding is not easy. You cannot just guide somebody how to do a new design. But otherwise, queries, you're always
Thank
so
you.
finally, I wish all of you all the very best. May God bless all of us. And may our geotechnical engineering practice grow from strength to strength and very soon reach international standards. Now, I want to share with you one more very lovely information. So 2 days back, I was in Chennai. There is a National Institute of Ocean Technology. A director currently is Ramadas, and apparently it seems I've advised him to join NIPT, and so he's very proud of telling me that I did that. He was telling me, sir, when we were in the beginning, when we interacted internationally, we were always, on the downside, we were always feeling deficient and, as if you're inferior. But nowadays, it's not like that. We feel equal to anyone while discussing. That is the standard we have to reach. That is Atmanirbhar Bharat. That is what we have to achieve. So with this, it's open for discussion. Please, Sirish, over to you.
Yeah, thank you, Professor Raju. It's very enlightening and very depth-wise, very great presentation. It opened up, I think, many questions. Definitely, we have time for 2-3 questions at this time. But if there is any long discussion going on, that we'll take it to the end, actually. So, any questions right now? I did not see any question in the chat box at this stage.
Sirish, I just want to make one more.
Please.
Obviously, whatever I said is probably 80% true, 20% not true. That means 20%. This is always the golden rule, 20-80 rule. So therefore, that is not really important. I'm sure there are people who are very competent. Actually, I just wanted to say that because we do a large number of projects in national capital and maybe already 120 gated communities or so during the last 5-6 years, we have only shortlisted 3 geotechnical investigation agencies. They're reasonably good and they're improving. So that's not the real point. The real point is it is not enough if 20% of the people are able to do good work. We have to at least reach 80%.
True.
Then only we can talk of a real study. Yes, I stop. Thank you.
So, any questions from the August gathering here in this particular panel? Probably we can entertain one of the questions before we move to the next presentation. And there is a slight change in the order because, as we all know, that Professor Sitaram is traveling, so he just requested us to move his presentation slightly later. So, next presentation would be by Dr. Ramakrishnan. So anyway, any questions that we have, we can engage for a minute or two.
Or it could be even a comment.
Yeah.
Brief comment. Question or a comment.
It's not a question, but from my side, there is a comment. You have rightly highlighted quality of investigation, manual versus instrumented automated system. So probably this will open up some discussion at the end. So it's just a passing, comment that I want to make here. And thank you very much for bringing that point out. And that's the key for the good investigation and appropriate answers for foundation design or any other design. Yeah.
That's wonderful. Amit is saying here that he has got the Japanese code. Thanks, Amit.
Okay.
You are our savior.
Yeah, that's great.
Yeah, one small point from my side, from the industry side. SPTs are being conducted using auto trip hammer, but we still have a confusion on what is the correction we need to use. And the energy is a hot topic now. What is the actual energy that is being transferred to the soil is a hot topic, although codes say that if you use auto trip hammer, it is 80%, but the measurements do not show so. So this is a big concern, and as Professor Raju pointed out, this affects liquefaction directly, which I have faced in a number of situations. Thank you.
Thank you, Prishman.
So then over to Dr. Prishman. Yeah, you can take over the form now. Yeah, thanks.
Good afternoon, everybody. It's a great pleasure to be with you all, and thank you, Muthukumaran, for having involving me in this great initiative of bridging the gap between the industry and academia. So now we have one great personality from the industry. Well, I do have a note which tells me about KSR, but I would rather like to introduce KSR my own way, because we used to call him KSR. He was in L&T. He has been in the deep foundation industry for a very, very long time. And he moved from Singapore, he came to India, then he is my Guru Bhai. So many commonalities are over here. So he is a great man, and the DFI in India is purely because of Dr. KSR. He brought DFI into India with all his efforts, and now we have completed 10 years and DFI is doing well. To give a short introduction, he has more than 40 years of experience in almost all areas of geotechnical engineering, especially diaphragm walls, dam cutoffs, marine structures, offshore platforms. He's a BE from College of Engineering, Kakinada, MTech and PhD from IIT Kanpur with Professor Madhav. And then he is a member, Board of Trustees, Deep Foundations USA. He is a founder member of DFI India, as I told you. He was in L&T ECC, then he played a role in L&T Geostructures. He retired from L&T Geostructures, and he has worked in various organizations. He has received the President Award in 2017 from DFI, and he has received Distinguished Service Award in 2020 from DFI USA. And that is Dr. K.S. Ramakrishna. Could you please switch on your camera, please, Dr. Ramakrishna?
Yeah, it is on.
There you are. So that everybody can see you. So I invite Dr. Ramakrishna to give his views on this interesting topic. Over to you, Dr. Ramakrishna.
Thank you, Dr. Kumar Pichmani, for your nice words. And thanks to the organizers for giving me this opportunity to participate in this important panel discussion on industry and academia interaction on geotechnical engineering practices. Without wasting much time, let me go to my presentation, which will not be for 20 minutes. I hope it will be less than that. Now, my topic is the bridging the gap, and that's what I think we're all working on for several decades. But the gap is widening, not closing. And in Professor Raju, with all his wisdom and experience, he has already covered a lot of it, what I am going to say. And you have heard it from the horse's mouth. And which my presentation will be mostly repetition, maybe small variation here and there. My experience in the field, what I realized is what is a comprehensive geotechnical engineering for a project. One is, as Professor Raju mentioned, soil investigation scheme must be appropriate and adequate to a project. Many times the client himself decides something and gets some report in a very, very short time, which is impossible to do, but he will create a report for records and keep it there. And based on that, a lot of feasibility works are done. Banks will give loans, enhance values, and all that. Most of you know what is happening in our industry. Soil investigation becomes only a kind of ritual, and that will have no sense for engineering. And what we need is an appropriate and adequate to the project, quality field investigation under qualified engineers supervision, and quality laboratory investigation, actual soil investigation, as Professor Raju mentioned. Quality engineering appraisal and recommendations, and which should be done by the engineering office, not the soil investigation agency. Should not put such a burden on soil investigation agency without knowing the structure and the performance requirements, project requirements, time and cost requirements. We should not ask soil investigation agency to give the recommendations, and which they make it as sacrosanct and proceed from there. So quality engineering appraisal and recommendations should be done by engineering office, geotechnical engineers and structural engineers together. The geotechnical design and foundation design and drawings must be appropriate for the site conditions and the project. They should not give some theoretical design of two parallel lines and a few dots in reinforcement. And that's all a well-designed drawing, and all other notes will be general standard notes and standard specifications. They have nothing to do with what exactly the site conditions and project requirements. Similarly, selection of technology, equipment, accessories, tools, methods of construction. This is the most important part because in my experience, the first part, first 1 to 6 will be covering about 15 to 20% of the project. Whereas balance is 80% has to be done, but most of it is done by non-geotechnical engineers. Selection of technology, equipment, accessories, tools, methods of construction, experienced frontline staff and equipment operators to carry out execution, and geotechnical engineers overall supervision and control of geo and foundation construction. This is very rarely done. Most of the time, geotechnical engineer is called only when there is a failure or some trouble. And he is more like a fire engine. He goes only after the fire starts, and very little can be saved. So, in my opinion, the geotechnical engineering, and unlike structural engineering, it is complete only when the construction is complete. Till that point of time, the geotechnical design engineer must be part of the execution. And in our country, I think most of the time this is not done, except in my experience in offshore platform, tile, and foundation design. Only there, the design engineer asked to be on board, but there will be a lot of issues, a lot of problems. So that is the only place where I find the geotechnical engineer is there throughout the project. All these 9 steps, he will be involved. He will be part of it, and he will make sure that because he is accountable and he is made responsible for the complete design and execution of the foundation. And this is, I feel, is the most ideal thing in a geotechnical engineer related to the project. Now, as Professor, everyone has before me mentioned, Professor Samadhya, KM Kumaran, and Professor Raju, knowledge, there is a huge gap between knowledge and practice. And particularly in our country, and of course, there will always be a gap between knowledge and practice. There will be a lag, but it should be not as much as it is in our country. The reasons are most of our geotechnical engineering degree holders are either in the teaching or they go to some other jobs. They end up become as structural engineers, or they go to software, or they go somewhere. But very rarely we find geotechnical engineers in the practice. And the last, I think, 10 years, I'm seeing some improvement in this. A lot of geotechnical engineers I'm able to see them. Our construction industry is very, very slow to recognize the value of geotechnical engineer. His services are called upon only when there is a problem or a failure, and it is too late to rectify. And just this morning, there was somebody who was sending me some drawings, some site photographs of some bottom heave and tension cracks in an excavation for a pipeline burial. So most of the foundation and geotechnical designs are carried out by non-geotechnical engineers, as Professor Raju has mentioned already. Almost all foundation and geotechnical works at sites are supervised by non-geotechnical engineers. It is the sad part. Most of the jobs are done by maybe somebody, some civil engineering graduate or supervisor. They will be supervising the work, and most of them are not equipped to know what exactly how the design is done, how the execution is to be done. Our geotechnical and foundation industry is not organized. These are the reasons why we started the foundation industry, the foundation institute in India, to cater to our industry. What exactly is, we know what are the gaps, and we try to help them. And wherever it is possible, wherever we are doing an event, we invite local geotechnical IGC, Indian Geotechnical Society local chapter. We make sure that we are working in collaboration with them, because unless academia and industry work together, some of these ills cannot be rectified, and we continue to talk on these platforms the same thing over and over for the next few decades. Because of these results, most of the time, there are failures, there are quality issues, and most of the projects suffer on cost and time delays, cost overruns and time delays. And there are statistics by authentic agencies in the government, some of the major industrial infrastructure projects, what is happening and what are the delays. Now, what do we do for bridging the gap? And of course, the platform is the right for this discussion, and improved academia and industry interaction exchange. So some of these things should be that some of the faculty must come into the industry, and some of the people in the industry must go to the classrooms. Some kind of this should happen. Include geo and foundation technologies, equipment methods, and should be in the curriculum of BTech and MTech programs. Because rarely, I think, this is done. There are so many technologies, because technology is the bridge between the design and the actual product. Only through technology only we do the actual product delivery. So that is not being taught in the institutes. If at least some exposure is given, the engineers coming out of these institutes will be more tuned to practical things, and they will like to join the industry. Otherwise, most of them end up in teaching. Creation of training institutes for frontline staff. Our ITAs and all that, the kind of people they produce, the polytechnics, they are not actually catering to the foundation industry. So polytechnics and ITIs also must be geared up to deal with the technologies aspects and equipment aspects of the foundation industry, because foundation industry doesn't have any support from these institutes. Make continuation education mandatory, like abroad. Every practicing engineer must, including people in the academics, should have at least 100 man-hours per annum attendance in conferences, seminars, and workshops. They should upgrade their knowledge, and then only they will know what is happening in the developed world. Make professional engineer certification, professional engineers in geotechnical, not a general civil engineer. Certification very, very strict and mandatory. And this must be this is a must, and we must make sure that every project is supervised by a professional geotechnical engineer. And legal action on owners and investigation agencies for inadequate, improper, and poor soil investigations. If owners do a soil investigation which is not enough, not appropriate, and in fact they must be sued, because the public money is involved in any delay or in a cost delay or time delay, and that no account for that. Nobody is made accountable. So owners must be made responsible for catering proper fund for investigation, and investigation agencies must be made accountable for producing the useful quality report. And a team from academia and industry to make a presentation to the decision makers in government, public, and private sector. This is not being done. Most of the time, in my observation, maybe I'm wrong, most of the time we are talking to ourselves. We are on these platforms. As long as we are talking to ourselves from within closed doors, the world outside will not know. The industry will not, the decision makers will not know the value of geotechnical engineer. And if this is done, and we must, maybe IG, Indian Geotechnical Society, and the DFI and IITs, some of these premier institutes, we must form some kind of a committee and go through it and make some presentations to the government, make sure that certain development improvements are done in the practice. Unless some of these things are brought into a legal framework, very difficult to implement. And that's all from me. Thank you for giving me this opportunity. Over to you, Dr. Pichmani.
Thank you, KSR. That was like an eye-opener, emphasizing on various aspects of the various practical aspects of investigation. Dr. Raju had spoken. I've heard KSR talking about this earlier also. And yes, these are various things that one needs to look into while doing the designs as well as execution. As Dr. KSR has said, geotechnical engineering is complete only after the construction is complete. That is absolutely true. That is what we also face in the industry. Thank you, Dr. KSR. We'll keep you posted with questions that crop up. As of now, we would rather get questions at the end of this seminar is what we feel. Thank you, Dr. KSR. Dr. Sirish, can you take it ahead?
Yeah. Thank you, Dr. Pichmani. I think Professor Sitaram is here. Thanks for joining back. I mean, he's still online throughout his journey back to his office. Professor, you're muted. Okay, so let me take a opportunity to introduce Professor Sitaram. I mean, it's my great pleasure because he's my guru at IISc. So currently, Professor Sitaram is a director IIT Guwahati and a senior professor of Department of Civil Engineering, IISc Bangalore. And he has been a very active consultant, and his research interests are in geotechnical earthquake engineering, seismic microzonation, and coastal reservoirs recently, and has been guiding several PhD students. The number is more than 70 right now, and published many good articles at reputed international level journals. So with this small break introduction, I request Professor Sitaram to present this lecture. Over to you, Professor.
Yeah. Thank you. I'll just let me share my presentation.
Sure.
Can you hear me?
Yes.
Can you see my presentation?
Yes, ma'am. Yes, sir. It should be in presentation mode.
Okay.
Yeah, good now.
Thank you. Namaste to everyone. Very good afternoon, Professor Raju, Professor Dr. K. Ramakrishna, all my good friends from IGS, Professor Deepankar, Satyendra Mittal, Dr. Sri Ravi Sundaram, Ravi Kiran Vaidya, Murali Krishna, Sri Devi, Partha Sarathi, Vetri Selvan, Nilima, and I don't know whether I left everybody, but anybody, I'm sorry. Very good afternoon. It's a great privilege for me to be here with you, with all the friends of geotechnical engineering community. President IGS, Professor Samadia, and all my good friends from Indian Geotechnical Fraternity. Good afternoon to everyone. So today's panel discussion is an academia and industry perspective on geotechnical engineering challenges. So there are basically three keywords: academia, industry, and geotechnical engineering challenges. Anyway, let me congratulate the IGC 2021 team led by Professor Muthukumaran of the Trichy chapter to come with such a innovative panel discussion with giving an opportunity to present each view of both academia and industry. I'm happy to be part of this panel discussion. I congratulate them, and I'm happy to see many distinguished colleagues delivering talks in this panel. Today, on this panel discussion, I invite all the young geoprofessionals to the future of geotechnics to explore the future of our profession. As Professor Raju was highlighting, there is a complete change in the way the profession has been done elsewhere in the world, and we need to catch up in India. Friends, soils are made by nature and not by man, and the products of nature are always complex. As soon as we pass from steel and concrete, that's what we learn in civil engineering, to earth, the omnipotence of theory ceases to exist. So with these complexities, we need to explore the intersection of mitigation of climate change, adaptation of climate change, and technology. And disruption in our technologies like AI and big data, cloud computing, all in geotechnics. I'm not talking about in electronics. To solve highly complex, large-scale infrastructural challenges, I'm going to show you some of them today. What we need to do? What are the imperatives? What is the must thing one need to do? So the goals of, if I understand and put it in a perspective, what are the goals of my panel, this panel discussion is to understand the perception of the university teacher or a researcher, no more a teacher now because he is going to be a researcher as per the NEP 2020, and also the industry engagement among industry practitioners and academics to elicit possible measures to improve the current situation by increasing the engagement, to identify the ways in which universities can play a larger role in bridging the gap, what Dr. Ramakrishna was highlighting, bridging the gap between industry and academia. So to do this, I think we need to collaborate. Networking and collaboration is the key in this job of bringing academia and industry closer together and reduce the bridging, reduce the gap. So we need to understand together some of the most important questions and challenges our society will face in the next 50 years. As I told you, the imperative, it means in an English dictionary, an essential, an urgent thing to look at. So I will definitely not go into prediction of what happens in the future, but I'm going to address what is going to be the geotechnical engineering role in future generations, so that how important that we come together as a community, both practitioners and the researchers at the universities. There is no doubt that the type of geotechnical problems are changing with time. I think I will show you some of them, the scale at which we are trying to do, what our teachers were trying to do, and what we are trying to address are quite complicated. As Professor Raju was highlighting about the Delhi International Airport and other projects, they are huge. One of the world's largest airport and best airport, such kind of a thing we are now hearing in India. Consequently, new studies, tests, analysis, strategies, and methodologies have to be also developed to provide smart solutions to present and future needs. How this is possible for only an academician? It's not. I think only, not even for industry. So they need to embrace each other, work together. So in addition to all these, the natural anthropogenic hazards such as earthquakes, landslides, flooding can strongly affect the built environment and the life of our communities. You have seen, because of climate change, these disastrous activities are also increasing in trend. So understanding and finding solutions for risks to which our society is currently exposed is important, and geotechnical engineering definitely plays a major role. So we need to look at multidisciplinary approaches, linking geotechnical engineering, data analytics, robust probabilistic frameworks, which can be the key to reduce future risks and ultimately improve the resilience of our society to natural and anthropogenic hazards. Further, the scope of geotechnical engineering is immense in the technology-driven world, both professionally in teaching as well as in the infrastructural design and execution. The way we do now infrastructural design and execution is completely changed. This is what I'm going to focus to you, what is called as you go approach. The field testing, laboratory testing, and the design will be going in tandem in iterations. So developing or a developed nation going for a huge infrastructural projects undoubtedly needs geotechnical engineering know-how, particularly that goes without saying for India. So whether it is in the area of energy, water storage, water supply, housing, technologies like even the wireless communications. So let me begin with a quote from Geotechnical Engineering Market Analysis. Market Research Future predicts the global geotechnical engineering market to grow at a rate of 6.5% CAGR from 2020 to 2027. So the global geotechnical engineering market is expected to develop rapidly in the coming years, owing to rising per capita disposable income and technological advances in geotechnical engineering projects. This is the second part of which I would like to highlight to you, that is the technological advances, wherein we need to tie up with the industry to use the state-of-the-art, machines, equipments, and methods, processes, and execution plans. So elevated demand for residential and infrastructure in emerging countries like India is expected to propel the geotechnical engineering industry forward in the coming years. One of the developments of the construction industry that is expected to fuel demand for geotechnical engineering designs over the forecast period is a greater emphasis on innovation in construction material. However, during the forecast period, a lack of skilled labor could be also a major restriction. So that's where I think India needs to really propel itself to train our people at the construction site, and safety and other risk issues need to be handled, whether it is the space of underground, city space, or smart cities projects, slope and excavation engineering, or ground and foundation engineering. So these are some of the topics which really needs attention of both academicians and industry people. And this is particularly more so, particularly we have started using tunneling and underground construction projects, a large number of them, both in urban and also in hilly regions of our country. So, which further boosted the growth of the overall geotechnical engineering market. So on the basis of application, global geotechnical market has been segmented into many sectors like municipal engineering, hydraulic engineering, bridge, tunneling engineering, mining engineering, building construction, housing. In all these sectors, we are expected to grow. So we need to expose our students and faculty to open innovation with collaboration, considering offering incentive to faculty and students to involve high-ended research. So the imperatives of this collaboration should be between industry and academia is the key to catalyze innovation and growth in technology. The best practices needs to be followed to improve the effectiveness. So for example, even we need to inculcate design thinking in our students, which is not there in our, at least civil engineering. Academia should focus on providing practical knowledge, and the newer innovation, newer technologies which is coming into the market should be brought in. Industrial partners should have the internal capability to absorb research. So the industry also has to learn. It is not just the role of the academia. So fully to understand and absorb the research fully and transform it into marketable products. What is most important is, what we have seen in the area of architecture, we have to see in civil engineering. So we need to impart entrepreneurial skills to drive research adoption in civil engineering, particularly in geotechnical. So particularly thanks to the Government of India, for the National Education Policy 2020 has envisioned the establishment of liberal, multidisciplinary and interdisciplinary research and innovation ecosystem. So just to highlight to you, the geotechnical engineer role will be also very complex in the future generations. As I told you, the nation is going for a huge infrastructure projects. Undoubtedly needs geotechnical engineering know-how, irrespective of the area, whether it is high-speed trains, tunneling, smart cities. So to solve some of these problems, multidisciplinary approaches linking geotechnical engineering, data analytic, robust probabilistic framework is the key. So some of the conventional the learnings what we had earlier has totally forgotten, and we are behind concrete as a material. I think we need to relook at this particular problem as a civil engineers. So there is a fantastic scope to look at soil as a material, as a construction material in many, many places. And this, the seismicity also is going to be a very, very important for us, because our zones are being upgraded and we are seeing large number of events happening in our region. And as a president of the Indian Society for Earthquake Technology, we feel that there must be much more awareness of those activities and how do we integrate the infrastructure development and all those natural processes which happens because of earthquakes. So the link between infrastructure development is not once for all an affair. It's a continuous process, and in development, which has to be preceded and accompanied and followed by progressive infrastructure. So rapid industrialization which improving for quality of life of people we are seeing, and which we are seeing that everywhere, every sector, including what we saw in the Kashi Vishwanath temple very recently. So the one more important thing we need to look at is we need to remember the sustainable development goals while executing our projects, wherein both industry and academia should understand the need for implementing the sustainable development goals. And our Honorable Prime Minister has actually put a 10-point agenda on disaster risk reduction, mainstreaming the disaster risk reduction in infrastructure development, such as airports, roads, canals, hospitals, schools, and bridges. So in this, there are some of the important projects India has taken up and done elegantly is, I think, Atal Tunnel, Archana Bridge, Kolkata Metro Tunnel. I was very happy to be part of a couple of projects involved in this. And also we have built since independence, very large dams, 5,800 large dams. This is where I'm telling you, the civil engineering audience to look at other than the concrete as a material. Please, we remember that we have built many large dams using concrete. And now, after 100 years, this concrete is not going to be there. So many of them, luckily, are also large earth dams. So which is actually, and what is important is we need to see is whether it is energy area or whether it is infrastructure sector, okay, for New India. So you can see the government projects, a huge opportunity for geotechnical engineering. So the world sees a new India in the 21st century, ladies and gentlemen. To make that happen, so we need industry and academia coming together. Some of the India's largest metro regions would be the size of many countries, both not just in terms of population, even in terms of GDP. Delhi and Mumbai is going to take over countries like Portugal, Colombia, UAE, Malaysia. Please note that. Only cities. Similarly, it is not the right side. I'm showing you the population. Definitely population, we know that we are already crossed. But what I'm talking about is GDP is also going to go. So there is an advantage. India, ladies and gentlemen, we are the third largest size of the GDP in the world. And where growth rates are also, maybe it is reduced due to pandemic, but you name like a road network, railway network, we are the largest in the world. Okay. And also the advantage is we have a very young population. So there is an advantage India promising very strong consumer market. And there are some important projects like Delhi-Mumbai infrastructure corridor or Dholera, and integrated townships. And many such projects actually requires the knowledge of geotechnical engineering. Friends, whether it is railways, ports, large number of work is happening in the aviation sector as well, as Professor Raju was highlighting, in the airports, and focus on affordable housing also requires, whether it is Amrut Atal Mission for Rejuvenation, Urban Transformation, or Pradhan Mantri Awas Yojana. And one such project, where I was involved just to highlight, how greater collaboration between academia and industry is very essential. So this is a project when we went there in the Chenab Bridge, which is across Chenab River after Katra. Okay, this is a very typical site with a large young mountains of the world, that is the Himalayas. And there is a highest railway bridge is coming up. So this is a railway line between Udhampur to Srinagar to the Baramulla rail link project in Himalayas with active young mountains, sub-zero temperatures, difficult to access, and a lot of disturbance. I don't say what it is, but what we need is new technological and innovation. This can only happen with collaboration of industry and academia. This is what I wanted to demonstrate, how we closely collaborated with the Afghans construction company, Indian Institute of Science, and we did this for almost like 10-15 years project. If you wanted to see where is that location, this is the Jammu Srinagar. The location is somewhere near Riyasi. This is where the bridge is going to come. I'll just show you. That is, this is up to this railway line is already existing. 2016 or 17, Katra railway station was inaugurated. And there is a railway line already, which is trains are running in the Srinagar Valley. But we need to connect between Katra to Banihal. And Chenab Bridge right falls in the center, and which is a very challenging site, which I showed you right now. So the infrastructure interactive designer observation method is the method adopted in this project, wherein, there is a TC 206 for looking at this of the ISMFGE. An interactive geotechnical design is a design approach that requires design refinement throughout the project execution period until a suitable technique and an optimum scheme are applied to the problem at hand. So, ladies and gentlemen, it is not just the way you test or a field techniques or a geotechnical testing. It is there. There is a lot things needs to be changed. The way you even analyze the problem and modify the problem. In general, the use of interactive geotechnical is not frequent. However, in large project, it is become an iterative approach. As we learn more about the ground realities, design is modified and updated. Whether it is railways, highways, power generation, mining, residential building, everything what is India is taking up is very huge projects now, and we require this approach in many of these problems. Depending on the importance of the project and the consequence of failure, elaborate geotechnical and geological investigations are required. Detailed analysis is also required, based on which slope stabilization measures have to be iterative and implemented. This is what we call design as we go, interactive geotechnical design. So wherein to establish this, we need to basically collaborate on a day-to-day basis with both the industry and academia. Academicians has to bring the research, newer research onto the table, and the practitioners have to bring newer technologies, newer method of execution, and newer materials into the field, so that we establish proper guidelines, because there is no guidelines. So technical recommendation within this framework. So the problem what we solved there is very highly jointed rock mass. We need to build what has not been done before in a very younger things. So I will not get into the detail, and similar projects, whether it is Kalpasar is another project which Government of India has taken, which is the world's largest reservoir for establishing a huge freshwater coastal reservoir right in the run of Kutch, or sorry, Gulf of Khambat. This is where, with 30-kilometer sea dam, the capacity to store 10,000 million cubic meters. When you do that, this will be the largest reservoir in the world, but the dam height will be very small. And this is what we need to look at, the newer solution, which I was trying to tell you. And this is where the location is. And this is where some of you would like to see the details of the project. It is available in the website called Kalpasar. Chinese have done it fantastically. They have built such a large coastal reservoir. Entire Shanghai city gets a clean water from this coastal reservoir called Chinkosa. And it took hardly four years to build. Hardly 4 years. See how much time we took to build Sardar Sarovar Dam, which is almost the age of Professor Sitaram, 60 years. See, Honorable Prime Minister, the first Prime Minister, Jawaharlal Nehru, put the foundation stone. Honorable Prime Minister Modi inaugurated in 2017 Sardar Sarovar project. So that's the kind of a problem we are in. We need to look at small and beautiful many times, but many times large projects. I will not get into the details of this kind of solutions. There are plenty of opportunities for us to look at, whether it is water, whether it is geotechnical. As a civil engineer, we need to build bigger things. So we need to look at that, as an institution also at IIT Guwahati, we are trying to bring in some of those, expand the research and innovation, nurture future leaders of the society at large. So our vision at IIT Guwahati was to recognize globally for excellence in education, research and innovation, nurture future leaders to serve society at large. So I will not take much of your time, and then, let me conclude. So I conclude with a statement from Swami Vivekananda: education is the manifestation of perfection already in man, and character is the test of that manifestation. Thank you very much, ladies and gentlemen. If you have any specific questions, I will take that. Thank you.
Thank you, Professor Sitaram, for a very enlightening lecture, and talking about the role of geotechnical engineering for current situation and for future innovations that yet to come. So if any panel members have any questions, we have time for 1 or 2 questions. Otherwise, we'll move on to the next presentation. You can unmute and speak if you have any questions from the panel. So thank you, Professor Sitaram, for your valuable time. I hope you will be here for our panel discussion and continue to be here until that point. Since there are no questions, we'll move forward. I request Dr. Pichmani to take over.
Good afternoon once again. So we had Dr. Sitaram talking about from the academia side on the industry and academia interaction. So as you see, we have two teams where we have an industry team and the academia team. So now what we do is we will call upon speakers from each of these teams, the industry as well as academia, alternatively, and each one of them will speak for 10 minutes. So let us start with the academia first. Dr. Sirish, can you introduce the first speaker? Then I will go ahead with the industry speaker next.
Sure. Yeah, I just gave you, transfer the platform to you to introduce something like on the panel discussion. So if you have any points, then you can make it. Otherwise, I can take it forward. I think, yeah, we'll give 10 minutes each. Then we can collect the questions, right? That's the model, right? Yeah, so let me introduce our first speaker from the panel A, which is academia. We have Professor Dipankar Chowdhury as our first speaker. He's a professor and Professor Tarun chair professor at IIT Bombay, and he's also head of the Department of Civil Engineering. So his research interests lie in, again, geotechnical earthquake engineering and the computational geotechnics and so on. So the list is huge. So we are anyway, we're cutting short on the introduction part. So I request Professor Dipankar Chowdhury to take over and give his presentation. Thank you.
Thanks a lot, Dr. Shirish, for your introduction. First of all, let me thank the organizers for having planned this such a wonderful topic of panel discussion for academia and industry bridging the gap. And I'm delighted to be here for a short, I will say, discussion. So as this is a panel discussion, essentially, I will look forward for the various points what the panel will recommend. And at this moment, I think the stalwarts like Professor Raju, Professor Sitaram, Dr. Gnss, they already have mentioned about that there is a big gap between academia and industry, and what are the things we want to do to reduce this gap, because we know that for better geotechnics, we need this gap to be reduced as minimum as possible. So I have chosen a topic of learning to execution as the theory to practice for the geotechnics. And I hope my slides are visible to all of you. Is the slide scrolling down?
Yeah. Professor Dipankar is good. Yeah.
Thank you so much. Thanks for confirming. So first of all, I must thank the industry partners. I feel that every day I learn from them by the interaction, and I'm really fortunate that they approached us at IIT Bombay in our laboratory, and we tried to find out several solutions for them, and most of them are challenging in nature. So of course, as I think Professor Sitaram rightly mentioned, that neither academia alone nor industry alone probably be able to solve those challenges. So that's why we need both. And that is why the both should come together. So these are the organizations, only few I could mention over here, for whom I am really indebted to them, because they approached with their field problems to us, and we tried to give the solution to them for real field projects, whatever we learned from the theory. What I like extremely good part about what we have seen in the presentation of Dr. Gnss, that self-introspection. I will try to do that first, because I think in a panel discussion like this, we hardly should discuss about the research topic or the academic presentations, as this is not the mandate of today's panel discussion. We should see where we need the improvement from our end. So I'm trying to focus on learning of geotechnics. So essentially the academia, what I'm trying to mention as learning of geotechnics. So as we all know this, that learning never ends till our life ends. And fundamental learning at academia is a must, because that is the starting point, as we all aware about that. But do not jump to practice without learning basics, because sometimes a few cases we found that people do start practicing it. Maybe they don't have that academia knowledge or basic knowledge on that topic. So that actually comes as a hindrance when they start practicing this. And learning can only be fruitful if someone loves it. Why I am telling so? Because learning cannot be forced on any topic, whether it is geotechnics or any other subject. We all know we only can do well if by heart we take the problem and try to solve it. That is, if our heart is there in that, then only our learning probably gets completed and we try to get something out of it in a better sense. Otherwise, probably if it is forced to someone, if somebody has been forced to do some geotechnics or some problem handling, probably it may not lead to a fruitful solution what is expected. Also, it is not necessary that everyone cannot or need not be an expert. Like everybody need not be an expert. We can have a variety of domain, and of course, experts can only be a few. This is the last point what I tried to recall and put from little bit of my experience, whatever so far I had, that many I found they enters in the geotechnics, I'm talking from academia point of view, not by choice or liking of geotechnics, but they end up entering in geotechnics by the virtue of their ranks or marks in various national and local examinations. Probably, first of all, at the beginning itself, civil engineering was not their liking. By the after 12, their examination rank or performance lead to force them to take civil engineering. So that is a compromise at the beginning they do. Later on, when they come for master's or higher studies, probably again another competitive exam of national level or local level, we found that most of them, as we know in our country and most of the countries, civil engineering is mostly oriented towards the structural engineering in the undergraduate studies. So when we talk about academia in higher study, then a very few probably will have that knack or that background of coming to geotechnics. So what happens? Most of the time, it becomes a forced situation to take geotechnics rather than by coming by choice or liking or loving it. So probably if that component is not solved at the beginning, it may not give a fruitful result. So that is what I think we should introspect, whether we are really liking geotechnics, whether we really need to be in the academia of geotechnics or so on. Coming to execution of geotechnics, which is essentially like what we say practice of geotechnics, competent executors are very few, but those they are not unavailable. Though they are very few, of course, such a big, not only worldwide, but in India also, with such a, if you see huge country with such large population, the persons who are knowledgeable about practicing geotechnics, the fraction maybe even in some few decimals percentage, even maybe lower than that. So then how to execute a good problem and good practicing engineers in geotechnics? Executors need to be subject and domain expert but should be open to learn new things and update knowledge with time. This is very essential. Otherwise, probably the practitioners, I think one of the expert already mentioned about this point. As you know, that suppose, and today's world, somebody is telling we will use the log slide rule and all those things instead of calculator and other devices or programs, probably that will not be useful. So one should update with the new things, new happenings. I'm very delighted that Professor Sitaram, like sir, always talks about the latest technology. I remember from my student days in IISc also. So this is actually give the opportunity the executors or practitioners, not only in academicians, but also the practitioners should update them with the latest knowledge with time. If they stop updating, probably that is the stoppage of learning altogether, and they no longer probably remain as a good practitioners, we know. Also, executors need to be most flexible for various options, like options in the sense what can be not only the safety. Safety is the first and foremost issue of any design, we know, mainly in civil engineering design, but also economy. A country like India, even now also, probably cannot or should not afford to such a unnecessary expenditure where it is not required. So no extra safety is available by spending more money. So then economy, good executor or practitioner only should be flexible to check for various options. It is not that we have done and one project for pile foundation, so other projects also we have to do pile foundation. As Professor Raju nicely mentioned, the Delhi airport probably initially they mentioned about pile foundation, but with his suggestion it went to the raft foundation, which is excellent. So these kind of executors should be free or flexible to opt out for various options or look for various options. Executor need to be confident enough and with highest ethical values. This is one of the most important. Many a times we see this is lacking. I think many of the previous speakers have mentioned about it, mainly because of the field testing and other results. We know sometimes the values are fabricated. In academia also, sometimes this kind of situation happens. But I will say, in case of practice, it is more dangerous because practicing geotechnique is like a surgeon. Like directly, any mistake is there, the structure will collapse, building will collapse. But probably somebody is doing something wrong in academia may not lead to killing of people or other things, but of course that is not acceptable at all. So highest ethical values is very, very essential in practicing geotechnics. And no need to run behind the money, because sometimes we found that many people, just because of little bit of extra money, they stop or try to fabricate the field data or other things. And reputation with time for executors only comes with the name and fame, that is good practice and proper practice, and that leads to money, of course, in due course of time. So from the beginning, one should be using highest ethical value for any practicing geotechnics. And unlike other civil engineering domains, as we all know, practicing in geotechnics cannot be generalized. It is not like superstructure, which some of the cases can be generalized probably, but in geotechnics, we know that each and every problem are unique in nature because of the type of problem what we handle. So it is not that in case of one oil tank foundation, one place piles were used, that means everywhere else piles to be used. So that is the openness probably an executors or practicing engineers need to be open to check and further follow. So I think that is the main essence of today's talk. I will just briefly touch upon what are the few of the things which we were involved in various cases. Like from academia, we talk about foundation, shallow, deep, and now composite foundation of CPRF. And this is the CPRF theories. Then the theory gets translated to the design code, design guidelines, and then in textbook or various edited books, as we know, various journal papers and other things.
Excuse me, you have maybe 1 minute, please.
Okay, okay. I'll come to a closure to that. And then when we implement it to actual field problem, that probably gives the bridging the gap between industry and academia. As we said, this is for the new nuclear power plant in Hisar, Gorakhpur. As we know, for NPCIL, we were involved for this kind of structure design and analysis. There are MTHL project, longest sea bridge of India with L&T and IIT Bombay. This is the execution going on, as you know. This is another largest fuel terminal in India. That is also with Kelar and IIT Bombay. We have done for IOCL. And this is the final picture we got few days ago from Kelar. And this is really a satisfying for an academia with bridging the gap with industry to see that these are coming in place properly and performing extremely well. So thank you so much. Thanks once again for your time. So if there are any doubts, I will be happy to clarify.
Thank you, Professor Dipankar. Very good lecture on, I mean, at least talking about learning and practice skills to be inculcated in a particular geotechnical engineer to be a, I mean, practicing geotechnical engineer. So because we are slightly running short of time, so we'll keep the questions at the end. Thank you so much for your time. And please be here and we'll have a panel discussion at the end. So we need your inputs at that point. Yeah.
Thank you so much.
Sure. And over to Dr. Pichmani.
Thank you, Suresh. Now let me call upon Shri Ravi Sundaram from Gnss. So Ravi, we know Ravi Sundaram quite well. He is very much known in the industry. So he's the founder director of Gnss Geotechnical. So let's not, since everybody knows him, just a few things which I would like to talk about him is he's been involved with IGS for a very long time. He delivered the prestigious 6th Madhav lecture. Then he has received the IGS Delhi chapter Lifetime Achievement Award and also IGS Professor Dinesh Mohan Memorial Award in 2017-18. So I welcome Mr. Sundaram to deliver his talk. Sundaram, you have 10 minutes to talk on this interaction from the industry side. Thank you.
Thank you, Dr. Kumar Pichmani, for that kind introduction. I will be talking about geotechnical engineering practice, present status, and future directions. So as you know, geotechnical engineering is everywhere. So it's a support engineering for all civil engineering disciplines, whether it's structural engineering, earthquake engineering, wastewater treatment, transportation, urban infrastructure. The list is very long, hill area development and all that. The trend today is to build big and building cities, building major structures, smart cities are the future of the country. Infrastructure, industrial development, industrial plants, power plants, refineries. The transportation sector is very hot with railways, metros, roads and bridges, and of course, culture and architecture. We've seen many of the recent projects, Ram Mandir and Ayodhya and Banaras and all that. So geotechnical engineering services are required for all activities. What's required today for the new geotechnical engineer is a multidisciplinary approach. So if you would treat civil engineering as a subsector of civil engineering, then that's a very narrow perspective. It would lead to an inadequate solution. You have to widen the understanding of the problem, interact with professionals of different disciplines, link with all other disciplines, whether it is geoscience disciplines like geology, mining, environmental, etc., or whether it is even mechanical, chemical, electrical engineering, to understand the behavior of machines, their tolerances, their environmental impact. All these become very essential for the new geotechnical engineer. So acquiring knowledge and skills, creativity and globalization. This is the new paradigm for all engineers. So how do you navigate between these different bodies of knowledge? What essentials skills are required? So modern geotechnical engineers has to go beyond the classical geotechnical engineering and the geotechnical structures, simplistic methods of analysis, etc. You have to face new challenges in environmental engineering, ground improvement, engineered barriers, rock mass behavior, sustainability, energy production also very important nowadays. So the concepts of safety and reliability have undergone a lot of change. From the limit equilibrium, ultimate bearing capacity divided by factor of safety, we have gone on to ultimate limit state and serviceability and systematic variation, evaluation of the variability and uncertainty. That's important, and statistical and probabilistic approaches have gained attention. So if you will look at theoretical versus practical research, computers have, of course, revolutionized theoretical analysis. Solutions that were not easily possible in the past have become feasible. But the flip side there is that the observational method, use of engineering judgment, that has started to become less important. If we are going to look at the computer programs and the finite element analysis, you miss out on such important things. So field monitoring and instrumentation, that is what is required for a better understanding of soil behavior. So if you could input the field data into your computer model and back calculate and update your design, that would be the right approach. So therefore, research and development should address non-quantifiable factors beyond the textbook situations, field experience of the engineer, so that your solution is reliable, economical, practical, and also amenable to speedy construction, so that the performance of your structure is as envisaged. So the geotechnical engineer has to consider field studies, success stories, failures, so that you have a flexible and systematic approach with proper choice of geotechnical investigation techniques, so that you are able to select a suitable analysis methodology, select your design parameters, all based on sound engineering judgment. So that's the geotechnical input pyramid. And as you were to move up along this pyramid from bronze to platinum, your factor of ignorance would reduce, your reliability is enhanced, there is a reduction of foundation cost and time, and you minimize the possibility of failure. Now, as you go on from bronze to platinum, you can see that there is a increase in the reliability of the design. However, there is also an increase in the cost, but we have to realize that whatever additional you spend, you would save much more in the construction. So my advice is move to gold and platinum levels, avoid the bronze level investigation, use advanced testing methods. Now, SPT is being supplemented by measurement of energy transfer for greater reliability. As Professor Raju said, electric cone, measurement of pore water pressure in the cone penetration test. There are other tests like dilatometer, pressure meter, and all these tests are very much essential for better assessment of the soil characteristics. And increased use of geophysical testing and remote sensing can give an additional support data, and advanced sampling and lab testing methods. And of course, remote data acquisition is also nowadays becoming very popular. So if we look at the areas of improvement of academia industry interaction, one point I would say is increased reliance on field instrumentation, so that you are able to adopt these technologies effectively for a safe design. Another improvement method is, of course, engineering analysis tools. use of reliability and risk analysis, serviceability criteria, value engineering, probabilistic approach. Of course, centrifugal modeling and numerical analysis has been done. And the Eurocode also is a very good guideline on how to do these things. Another very important thing is that the soil investigation program must be tailor-made for the project. Let us not have that concept of having a standard specifications. And of course, nothing can replace good engineering intuition or engineering judgment or the feel of the soil. All of us have this, have heard this cliche one time or the other. Geotechnical engineering is a science, but it's practice and art. So let us make this art very effective. So this is the disconnect between research and practice. You see the researcher here doing complex finite element analysis and fuzzy sets, whereas on the side, the undisturbed sample is being collected in a not very standard way. So this has to stop. So the geotechnical engineering selection process, of course, there is a big issue here. And the L1 technique discourages innovation, it discourages technical enterprise, it encourages malpractices. So consultancy is worthless if the quality of the data is poor. So we have to be aware of it. So a planned investigation can lead to substantial savings and foundation cost and mitigated the risks. We have to realize that one shoe can't fit all. So different solutions for different sites. Of course, retrofitting is more painful and involves very high costs. So geotechnical engineer must be capable of going beyond the codal provisions when required. Difficult soil conditions, out of textbook situations. This is something which the industry keeps facing. So again, if we were to go on to the further areas of improvement of the academia industry relationship, let us try to make sure that investigations are not unilaterally decided by the owner, architect, or the PMC. The geotechnical engineer has to be a part of this right from the beginning. And typically the scope is insufficient. Therefore, thereby the geotechnical engineer is handicapped right from the start, and he gets criticized for not doing enough tests. But when the scope is defined in that way, then the investigating agency also is at problem. And the geotechnical engineer is forgotten once the report is submitted and remembered only when a failure happens. That's the problem. So we have
one more minute, Ravi Sundaram.
Yes, sir, I'm finishing.
Thank you.
So we have to work together so that to make sure that the structural engineer and geotechnical engineer, PMC, all of them are blissfully unaware of each other, no discussions. And if there is proper coordination, we have an iterative design process, then and reverse feedback that will help your design. So to be able to realize the design on the ground, you have to have a continuous involvement of the geotechnical engineer on the ground, regular design meetings, QA, QC reports, all reviewed and taken care of, not thrown into a pile of reports. So instrumentation, all that is what I would propose. So if we were to look at a situation like this, however good your design is, these kind of piles are obviously not going to perform as designed. So the future has to be technology oriented, remote data acquisition, superior quality of sampling, laboratory testing, advanced testing technologies, increased use of geophysical and a national database of geotechnical engineering plotted on Google Maps. That should help. And construction, again, modern piling rigs, equipment and ground improvement, increased use of electronics, technology, software, warning signals if something is not going right, ground improvement technologies, more efficient rigs, superior quality assurance, superior testing. All this is required to be able to, face the future. So let us discuss the various possible areas for improvement. There are various issues, right from the selection of the geotechnical engineer to the contractual issues, and of course, realizing the design on the ground. Thank you very much.
Thank you, Ravi Sundaram, for that interesting lecture. We don't have any, we will keep the interaction or question round to the end. Now I invite Sirish to introduce the next speaker, who's from the academia.
So from academia side, we have a very well-known professor, Professor Satyendra Mittal from IIT Roorkee. His expertise is more into soil nailing, ground improvement techniques, and pile foundations. He has been very active in consulting projects. I think he has completed more than 1,000 such projects. So let us welcome Satyendra, Doctor. Thank you.
Thank you, Professor Sirish and Mr. Pichumani for introducing me. And at the outset, I am thankful to the organizers for giving me opportunity to share my views in the panel discussion. Well, we have heard learned speakers before me, and it is true that academia alone can't do anything without industry and vice versa. In limited time, I shall share some of the field problems handled by me in the recent past, as desired by the organizers also. And all these problems are related to ground improvement. Well, Mr. Ravi Sundaram just now said a very good sentence. That was that we have to develop the design out of textbook. So, well, I had been mostly handling very difficult problems in my professional life. So I would share with you in limited time the successful projects handled by me in very difficult conditions. So as the topic of my presentation is ground improvement, solutions for problematic soils and hill slope stabilizations, and some case studies recently handled by me, I'll be sharing with you. Well, friends, we know that the Romans had been adopting the ground improvement techniques. They had been deploying the oxen and horses also for the ground improvement. Later on, they had developed the indigenously made pulley also, through which they used to drop the wooden log to compact the ground. But nowadays, these techniques have been replaced by very sophisticated and heavy-duty rollers. And for the waterlogged areas, the bend drains are also used in the professional life. We all know that at the Salt Lake City of Kolkata and in Kakinada and in many other places, the bend drains have been successfully used. Well, we can experience ground improvement simply by doing a little experiment. That suppose it is a wooden box which has these 4 walls in all the sides, and these are the hinges. And because of the hinges, we can make this box vertical. And when we fill this box with sand, and if I stand over it, obviously because of the earth pressure caused by my weight or by humans' body weight, the side walls may deflect. But when I fill the box again with the help of some geogrid in between, then probably this time the side walls will not deflect. So this is because of the friction or because of the apparent cohesion. I'm sorry, these slides are not advancing. So let me just try.
Sir, you may reconnect this presentation again.
Okay, stop sharing.
Yeah, stop sharing and start sharing again.
Yes. And we can verify this, whatever discussion I told you just now, that this is the same wooden box, and you fill the material without geogrid, it will collapse when you remove the walls. But when you provide the geogrid in between, the soil mass will remain intact. So this is because of the cohesion, or we can say the adhesion which is developed between the geogrid and the soil particles. Because of that, some friction is generated, and because of this friction, the soil gets confined. So this fact we can utilize in any kind of soil problems. Suppose we want to make a basement, or we want to stabilize any hill slope, then if I provide some foreign body into the soil, which can be nails incidentally, then the soil mass gets stabilized. It can be stabilized even for more than 100 years. So length of this nail is sometimes provided as 0.7 times of h, where h is the height of slope, which has to be stabilized. So we can use this fact for basement construction and also for the hill slope stabilization. And this white line which you are seeing in this is the failure plane. So length of this nail has to be such that it penetrates the failure plane. And when we do this, this yellow line is the wire mesh, and this blue line is the base plate, and the this brown is the nut, which is tightened and which is followed by the shotcreting. So by this we can stabilize the soil. And recently I handled one very, very difficult problem in Mata Vaishno Devi Shrine in Kashmir. Professor Sitaram also discussed the Chenab Bridge problem. And in Kashmir, there are multiple problems. And the role of geotechnical engineers is very pertinent in the states, hilly states like J&K also. Well, this is the Mata Vaishno Devi Shrine, which is famous, which is visited about 50,000 pilgrims per day. So this adjoining to this Mata Vaishno Devi Shrine, they had their guest house. And but because of the movement of this hill slope, this earlier existing guest house that developed a lot of cracks and the tilting also. So what they did, they removed that, they raised out that earlier guest house. Now they are constructing another 5-story guest house, which is called as Durga Bhavan. So when they removed this earlier one, a guest house, they provided a PCC retaining wall of 10-meter height, and whatever building material which was removed, extracted from the earlier Bhavan, they filled behind this retaining wall as a filled up material. So this was full of old doors, windows, and even wash basins and the sanitary waste also. So now the revised design is developed by School of Planning and Architecture, New Delhi, and they have designed, it's a 5-story Durga Bhavan, which will be constructed on the same hill slope. Now, as per the architectural design, one of the columns will come into this backfill area. So it is a very, very challenging problem, because in the earlier design developed by School of Planning and Architecture, they had suggested a pile into this backfill area. And the pile agency, they tried a lot to construct a pile here, but it was impossible to construct a pile because the backfill was full of doors, windows, as I said, even the sanitary products and all this material, waste material. So at this stage, they contacted me. So the ground improvement techniques became inevitable. So what I suggested them is that don't try to remove this material, because it was very, very difficult to remove this material from the backfill. What I said, that you provide a good soil cover and compact it up to the 98% Proctor density. Then I said that you provide the injection grouting by the chemicals, and it can be 2 inch with the 2 inches dia jet grouting at the network of at the spacing of 600 mm by 600 mm plate. And it will be done up to 2.5 meter depth, because 2.5 meter was incidentally close to the influence zone of the foundation of the stone column. Not a stone column, the RCC column, this RCC column. Now, what I said, that after compacting it and after doing the chemical grouting, injection grouting, you provide you conduct a plate load test there. And after that, if you feel that you are satisfied, if you are satisfied with the desired bearing capacity, then you provide a PCC raft, and above that, you provide a RCC raft, from which the RCC columns can emanate. So finally, this design has been approved by the CPWD, which is the executive agency, and now they are doing it. Now, at the same time, what I told them was that this retaining wall, if this is PCC retaining wall, you also provide the anchors, self-drilling anchors to protect this retaining wall. Because when the loads will come through the RCC column, probably this retaining wall could yield. So I asked them to provide the anchors, and I conducted the slope stability analysis for the virgin case, means without the anchors and also with the anchors. So with the anchors, I found that the factor of safety in the dynamic condition was coming as 1.33, which is acceptable. And this is the 3D view. So this solution is now being adopted. Now, this is the problem which I handled in Haridwar. As we know that in the beginning of this year, there was Kumbh Mela in Haridwar. So in Kumbh Mela, the large scale infrastructure development took place. And in the Haridwar city, a little outskirts of Haridwar main city, a train moves on the embankment. So because of the heavy traffic expected during the Kumbh Mela, the government wanted this embankment to be punctured and to construct a box tunnel and a underpass. So they wanted 2 underpass to be constructed. So again, I used this nailing technique here. So this was the earlier embankment. So these red dots, you can see these are the nails. So I inserted the nail just like this to reinforce the existing embankment. And these RCC, these tunnels were kept ready. The underpass was kept ready. And this was pushed through the heavy duty hydraulic jacks like this. And finally, all the nails were extracted and the underpass was constructed. So you can see this is the underpass, and now above this underpass, the trains have started moving. So
Professor Mittal, maybe 1 minute.
Yeah, okay, fine.
1 minute, please.
Yeah, so this is the Central University, Srinagar in Kashmir. The soil testing was done by some agency there, and it is all waterlogged area. And as you can see, up to the depth of 3 meter, 4.5 meter, the bearing capacity was 1.75 or 2.82 ton per meter square. So I provided the skirted granular pile foundation, and by this, the bearing capacity was improved to 19 ton per meter square, as confirmed by the test also, in the field test also. Well, this is the last example. This is the Jaipuri School, very famous school, one of the costliest schools of Ghaziabad. There, earlier, the architect had designed only the ground plus first floor. But the school became very popular and it became one of the costliest. They wanted to add another floor. But it was not a frame structure building. It was not a beam column type of foundation there. So they wanted to enhance the bearing capacity. So there I used this micropiling all around the plinth protection area of the Jaipuri School building. So this is the micropiling which were constructed, and now the third floor has been added, and very successfully. Well, this is same kind of problem I handled in Kolkata High Court building, and this is the northwest corner of the Kolkata High Court building. This is the one of the magnificent buildings of Kolkata. So Hooghly River is just on the northwest side only. So 4 years back, Hooghly River water entered into the foundation, and because of that, there was a differential settlement. And unfortunately, below this, the Chief Justice sits here only. So because of the differential settlement, there are a lot of damages. You can see the walls had cracked, even the arches had cracked. So there also I provided the battery of micropiles and followed by the grouting. You can see 2 types of grouting I had adopted here. One grouting was
Professor, can you conclude?
Yes, yeah. So this is for stopping the river water, and this was the consolidation grouting to enhance the bearing capacity of the foundation. So these are some of the case studies which I wanted to share with you. Thank you very much.
You're on mute, Sirish.
Sorry. Yeah. Thank you very much for nice presentation, Professor Mittal. We'll have the questions at the end. Actually.
Yes.
Thank you. Thank you so much. Yeah. Professor Pichmani.
Yes.
Dr. Pichmani. Yeah.
We shall go ahead now with the from the industry perspective. We have Dr. Sridevi Dade, Director, CSIR 4th Paradigm Institute, Bangalore. Her topic is GNSS-based geoscience research. To put Sridevi in one sentence, she is a pioneer in GIS-based, GPS-based geoscience research in India. She's done a lot of work since 1994. So let's hear from her, her perspective on the industry-academia interaction. Welcome, Sridevi.
Thank you. This is Sridevi Jade. But see, we belong to, see, people are calling us industry because we belong to Council of Scientific and Industrial Research. So when they invited me to talk about under the industry category, initially I was a little hesitant, and then but then he said it's okay, the work you do fits in. So then I agreed to speak. So I will now share my screen. Is it visible?
Yes, please.
Yes, please go ahead.
Yeah. So I little bit changed my topic to real time because industry interaction. So I said real time GNSS and natural hazards. I put in totally 10 slides, and I hope to finish each slide in 1 minute. So this is the title slide. I am an outstanding scientist and director of CSIR Fourth Paradigm Institute. This is when I was studying at IISc Bangalore. This was the GPS station. You know, GPS became operational in 1994. So that exactly this globally, exactly same time we set up this particular station in IISc when I was a student there at IISc. So I thought this is interesting to put. And the other one which you're seeing here, my cursor is visible.
Yes, ma'am, go ahead.
Okay, so this other one which you're seeing is our high altitude station at 4,600 feet in Hanle, Ladakh. And the rest all are, see, we have been having this GNSS network for almost like now starting from 1994 in different parts of the country till date. So that's almost like more than 25 years, I guess. Anyway, I'm not very good at that. So what I thought here, what I would share the industry perspective is that, see, right now the stations we have work 24 hours a day, 365 days a year. There are continuous stations, and we have few of them around 10, 15 are real time, which collect data both at 1 second interval and 30-second interval. So if we can use it, this sort of data to address the natural hazards, there the industry perspective comes, because, you know, that would be really beneficial, both like we can give some kind of this thing before a cloud burst, or we can give some real-time monitoring of landslides, glaciers, and of course volcanoes also we did, and also earthquakes, not in the sense like we can use it for earthquake precursor studies, not to give some kind of forecast or anything, which is right now not possible for earthquakes. So we are called Fourth Paradigm in this institute. Fourth paradigm means big data science. As you all know, first paradigm is experimental. Second is when you put equations and solve them analytically. Third is when you solve those equations using computers. And fourth is data intensive scientific discovery. So when you use big data for scientific discoveries, that becomes the fourth paradigm of science. When you use big data in Netflix and all that, but that's not, this basically fourth paradigm is meant to define data, big data for science. So we are supposed to be doing that for CSIR overall. As we all know, CSIR has got around 38 laboratories and few centers. And we host the high performance computing facility for the full of CSIR. So that is in a nutshell. So I just will give you a glimpse what all can be done with GPS. Then in the panel discussion, people can throw some light on how they want to use it for with industry's perspective. So I just very short presentation. So this is the brief outline of my talk. Basically, if you have a real-time GNSS network, right now we do have, but then it's only 10 or 15 stations are real time. Then we have all the models in place to use it for both earthquake studies, seismic studies, and to give stress strain maps, etc. And for landslide, glacial and volcano studies, to give precipitable water vapor and a little bit of forecast for extreme rainfall and cloud burst. And then we also derive total electron content from GPS. These are all products of GPS. Total electron content from GPS, which can also be used for ionosphere variability studies and also as a precursor for earthquake hazards. So this is my short outline. So first I'll talk about seismic hazard and GNSS. So this actually, in a nutshell, what we have done in last 25 years or more than that, since 1994. So all these triangles you see are all continuous stations. That is 24 hours a day, 365 days a year, they are been running. We have stations in the remote part of the country. Like the latest station which we have established was in Varsi. There is that is near Saichen Glacier, and whether you believe it or not, I went there personally in July. There is only one house there, one house. The whole Varsi village has one single house. When people were telling me when I landed in Ladakh, it is one single house, I thought they may be kind of joking. But when I went there, I saw there's one Buddhist family which lives there. So, and we have a station there. So I'm telling that kind of stations we have. And these small red dots are all episodic stations, which we measure yearly once. And the velocity vectors, which you can see as average vectors. That is, for all these stations, I put one vector, but each station, the result is like each station will have its own vector, because GPS gives you position over a period of time, but that's nothing but velocity. When we use GPS for scientific studies, you use the high-end one. So you get velocity precisely in millimeters with millimeter accuracy. So only for clarity, I have put these vectors, average vectors. So what do? We measure the surface deformation, and then we come out with surface stress and strain map for the region. Okay. Then we take the earthquake catalog and come out with the seismic strain. Then we do composite analysis of both seismic and geodetic strain. And then we would say what is the strain budget we calculate. And then we would say this strain budget is capable of producing an earthquake of this magnitude with this sort of recurrence interval. So that is one of the studies we do. The other study is what is the slip on the subsurface fault which is causing this deformation on the surface. So that is inverse modeling we do, and we give that also. And if there is an earthquake, like for example in Andaman we have an earthquake. So if there is an earthquake, we can measure what is the exact motion of the earthquake, and then based on that we can say what was the rupture during the earthquake. So like for Port Blair, we could pick up motion of around 6 meters because of the earthquake. This green arrow which you can see. So these are the kind of studies we do. So in Japan and all, they have real-time GNSS network of around 3,000 stations. And the 2011 earthquake, they actually gave a prediction 3 minutes before, if I remember correctly. But then that is too less a time to do anything, but they could give. So it is possible, and the basic underlying models and all is same everywhere. It is the same. It is just that whether you do it in real time or do it in post-processing mode. So before you do anything, when you see these vectors, these are all how the Indian plate moves in the global reference frame. But if you want to calculate what is the motion within our regional motion, then you have to find the pole of rotation of Indian plate. So this we have done. So using all these vectors, the Indian plate rotates like this. So what is its pole? And then we gave a pole here for it. So once we have this pole, then we can reduce the velocities to regional velocities. Like if you see Himalayas, we worked right from west to east in all parts of Himalaya, starting from Kashmir. This is the border. These are all Pakistan stations. So this is our border. This is the northernmost station. Then we did it in Ladakh. And again, there also there's a border. And then we have full up to Arunachal Himalaya. So basically, this kind of work we do for Indian Himalaya. So if you go to Garhwal Kupion Himalaya, we did the composite analysis of seismic and geodetic strain and said that a magnitude 8.5 magnitude earthquake is anytime possible in this region. So if it comes, then like I can say that Delhi would be severely affected. Then,
Dr. Sridevi, 2 minutes.
yeah, and then I have, I think, 2 more slides. And then this is the same thing which we did for Kashmir. Then we go to landslide. This is the real-time monitoring of landslide which we have done in Garhwal Commune region, and these are our station setup. Everything is published so people can. So here we have used all geotechnical instrumentation and GPS instrumentation and integrated it, and we monitored this landslide for 7 years. So this is one of this thing. Then water vapor. So this is the water vapor column at all our stations, continuous stations, which we got through GPS. And here, basically, this column shows the bias between the models, model given water vapor, like MODIS, and the actual water vapor. And the background is basically MODIS water vapor contours. So we show what is the kind of budget we have between the models and the real time. So if you introduce this real-time water vapor into the weather forecasting, then you would get precise weather. So like when you see, this is our Hanley site, I told you 4,600 feet. So this is the correlation between water vapor and rainfall. And we could predict the 2006 cloudburst of Ladakh, the red color 2006 cloudburst of Ladakh using our water vapor models. So if you have real time, the real time water vapor goes into weather simulation models, and you can improve your weather forecast in real time. And then this is my last slide, where we use GPS for ionosphere studies. So this also, as you can see, shows the, if you GPS water vapor is the most precise. So sorry, GPS ionosphere is the most precise, that is the total electron content. So we compared with the modeled one that is given by IRI, and you can see the bias at all the stations. So that kind of error is involved when you use modeled ionosphere, even whether it is for precursor studies or ionosphere variability studies. So this is what we have given, and this is a plot where we have plotted the variation of ionosphere with respect to solar radiation flux, sunspot, and RMSE. Thank you. So in nutshell, what I want to conclude is, if we can have this real-time GPS in collaboration with industry, set up the network, or the network we have can be made real-time, then we can address these natural hazard problems in the real time, which will be, we can give a forecast whether for a cloud burst, even for earthquakes, we can give a little bit in advance some kind of thing that this place is going to have not like at this time or anything, but is most probable to have an earthquake in the near future. Thank you. I think I am on time.
Yeah, sure. Very interesting, Sridevi. Mix of real-time monitoring and geotechnical. Absolutely, I think we will be able to address a lot of these landslides issues that we face in the Himalayas. Maybe I should raise that question during the panel discussion. Thank you once again, Dr. Sridevi.
Yeah, thanks.
Right, then we have...
Okay, I'll stop sharing.
Yeah, thank you. I think we have now Dr. Amit Prashant from IIT Gandhinagar. He's a professor and a dean academics at Gandhinagar, IIT Gandhinagar. His research interests include, constitutive modeling, numerical analysis in geotechnical engineering, including earthquake engineering. So let's hear from him what he thinks about this collaboration or perspective about academia and industry on geotechnical engineering. Over to you,
Shirish.
Yeah, Prashant.
Thank you, Shirish. It is my pleasure to be here, and thank you for inviting. And the perspective that I want to present is actually one of the strongest possibility of collaboration is in development of codes. And the experiences that I had, one of the experience I'm going to present here, but I have seen codes being developed from initiative of academia versus the initiative from the industry side, and how the advantages you can say are there in two different approaches. I think that is something to look at. The most important component in code development is spending time on that and going into, you can say, the details of different aspects of implementation. So that is where I think sometimes it happens, sometimes it doesn't happen. And that's where I think industry and academia should come together and work on these aspects. The strong, you can say, codes, you can say, accompanied by commentaries, which are completely missing most of the time. So commentaries is another aspect where we should work on in collaboration between academia and industry. So these perspectives, I think, will align well if we can talk each other's language, and that is possible through joint code developments in a very serious exercise, serious manner, we can say. So here I'm going to talk about the design of bridge foundations in liquefiable soils. Recently, about 4 or 5 months back, we had submitted recommendations to IRC for you can say bridge foundations in liquefiable soils. In this group, the chair was Professor Tandon, who is actually industry person, and Ravi Sundaram was there, of course, and many industry people were there. And I think Devashish from Kharagpur and a couple of people I think were there from academia as well. So it was a very, you can say, enlightening exercise where we saw that how much industry knows about these issues, although there were no guidelines available anywhere in a way. And so by handling the situation, by handling the issues, by looking at various codes worldwide, I think they have been able to manage the issues. And that was consolidated into this, you can say, guidelines. So we know liquefiable soils have dangerous effects on bridges many times because they're unconsolidated soils and covered issues and so on. Those are there. But beyond that, liquefiable soils remove the support from the piles that are used in the foundation or caissons. So there are several such examples. We have all seen many pictures of these in various presentations. Generally, the bridge foundations we talk about either are piles or caissons. India is full of bridge foundations as caissons in rivers, etc. And if it is land bridge, then it is more like a pile. That is the general practice. But so these are the two major, you can say, components that are there. We know various modes of failures from various case studies and how they have impacted the design strength or the designed sections of the piles or caissons. So those case studies, I think Japanese and mainly Japanese actually, they have done a lot of work on this. So they could develop very good guidelines for how to consider loads, how to consider, you can say, the analysis mode, etc. So that is something to learn. And this diagram is coming from the guidelines of, you can say, the Japanese code. I think Professor Raju was mentioning about Japanese codes. I shared with him. This is where I got those codes actually, you can say, while writing this chapter in the guidelines. So in this, if you look at, it says that when we talk about liquefiable soils, they still carry some strength. And depending on what is the factor of safety with respect to the liquefaction, the strength is there. So assuming that zero strength is not going to work. So rather that strength actually imposes loads on the piles and caissons, and that load has to be factored in. So how much is the load that they have kind of suggested in the non-liquefiable soils above, that is passive resistance that is offered by the soil on the you can say the vertical element, whether it is pile or caisson. And in the liquefiable zone, it's more of an overburden effect that is there. And that is 0.3 times the overburden that is acting as a gravity load, you can say, in horizontal direction. So that is to be considered as a load, while some strength is available. So horizontal resistance is also available in the zone of liquefaction as well as above. Now, how much is the reduction in shear strength that I should consider in that zone? That is also they have identified based on the factor of safety, as I was mentioning. So if factor of safety is very low, you have, you can say, you have factor very low. So strength is less. If factor of safety is higher side, then strength is significant in a way. So we should account for that. That is the point. So we can't just say that it's zero all the time. So in the modeling part, the issue of stiffness is always there. The codal provisions, IS code 2911 suggests some correlations, But of course, whether I can use those directly or not. So we did some study comparing IS code recommendations with Japanese codes. And based on that, we found that there are some variations of, you can say, the recommendations can be used in that. So that way, you can say the correlations that are available in IS code, we tried to fit with that itself. For piles, it was okay. It was not too bad, I would say, but for caissons, it was a big issue. So that is where we had made some modified recommendations. I'll come to that in a bit. So for piles also, there are various springs. So this is another aspect. So when we were discussing, we thought that whether we should go for 3D simulations kind of, or spring model kind of things, and how simple that should be there. So that's where I think discussions between industry and academia is important. We think everything should be perfect as academic, but in practice, you have to also see what is feasible and what is economical to design, spending how much time is available for design, etc. So that's where we had discussions, and we came down to a very simple model where we have some springs put on the piles representing the soil around, and how much is the coefficient you can say we should put. Another discussion is whether we should take linear or bilinear type response or non-linear type response, PY curves. So eventually we compromised in between, where we said it will be linear springs with some strength at the top kind of thing as a cap, you can say. But there are 4 springs that are involved. Lateral springs, 3 springs that are involved. So lateral springs, vertical springs, and at the bottom of the pile, you can say. So lateral springs and vertical springs on the side of for the friction, we can say. So these recommendations are there in different codes in different ways. We had a lot of discussion on this, how much is in practice we have experienced. And based on that, we came down to our own recommendations on that by looking at what others are following, of course. So this all has been compiled. If anybody is interested, I'll be happy to share that information. So in a way, what we summarized is we have to consider load on the piles due to the non-liquefiable layers, which is huge load. And in liquefiable layer, there is a gravity or overburden load that we have to consider. At the same time, there is marginal strength available, not much strength available on that zone as well. And of course, grip length below in the pile, below the liquefiable length, liquefiable layers is going to provide rest of the resistance. And accordingly, we can find out how much strength to provide.
For you have 2 minutes.
Yeah.
Sure.
For multiple piles, of course, there is a leading row, which has almost like same response as single pile. But from the back, how much reduction has to be done? That is the only difference between single pile and multiple pile system. But at the same time, the analysis has to be done jointly. And that is the model we have suggested in the whole process. For caissons, of course, again, there are several springs that we have considered eventually instead of doing the 3D analysis for seismic design. In this springs, the recommendations have been adopted from the Japanese code, JRA, but the coefficients, the stiffness was again an issue. So we did comparative studies, and based on that, what we found is if we follow the recommendations of bowels that Professor Raju was mentioning, I think in this case, it will be difficult because the strain values are very small. And that's where we rationalize it by saying that if we look into the strain effect on the modulus, so accordingly, we can go for 3 times the stiffness value compared to what code suggests for piles. And that comparison was very well in line with what Japanese were saying in a way. So that way we could adopt this recommendation after this analysis we could do. And with that, we came down to a consolidated chapter on how we should design in the liquefiable soils for bridge foundations. So with that, I'll end my presentation and I'll be happy to discuss during the panel discussion.
Thank you, Amit. I think it's very on time. Then we'll take the questions at the end. Thank you so much. Dr. Bishmani, it's over to you.
Yeah, thank you, Amit. Very interesting topic, very relevant to industry, which we are struggling with. So we'll raise these points maybe in the end. Right, next we move to the industry speaker who is Ravikiran Vaidya. So Ravikiran Vaidya is popularly known as the pile testing man. That's what I will call him. All types of pile tests, whether it is actual tests or it is indirect method of testing. All this is Ravikiran Vaidya. He runs his company called Geotechnics. He has done a lot of pile load tests, and the latest is the monopile that he has done for coastal road. We have done monopile for the first time in India, large diameter monopiles on the coastal road in Mumbai, which Ravikiran has tested. Over to you, Ravikiran. 10 minutes.
Thank you, sir. Thank you for the introduction, and it is a pleasure to present my viewpoint in front of all the experts, and hopefully I'm able to do that justice in the next 10 minutes time. Let me share my presentation. So I'm going to talk on ethical testing practices in foundation engineering in terms of geotechnical testing and instrumentation. And of course, we all know that damages due to foundation failures can be catastrophic. And you all must have seen these two slides, but this was one slide where fortunately or unfortunately I was also involved, and we were on the right side, so we were saved. But that is something which can have long-term consequences. So very, very important to be ethical. So is testing essential or secondary? I don't think we have any doubts on that. It's a requirement. So when I talk of pile foundation testing, I think the most important aspect of the entire structure is that when you're testing pile foundations, nothing is visible, and yet we transfer large loads, I mean, to the tune of 10,000 tons or more from superstructure to substructure in the belief that it will be good for 100 years or even more, because I want my foundations to be like British times. I don't want to keep on demolishing the foundation. So we really want it to last 100 years or more. And then the problem is the entire process of construction and testing is complicated because you need knowledge in terms of concrete, in terms of soil, its theory and equipment and so on. So it makes it more complex and challenging. Then again, when we talk of testing, a lot of times we end up being like a forensic engineer because not much information is provided before the test or report submission. It's only when you say that things are bad and then all the information starts pouring in saying that nothing was actually wrong, but you still end up finding something or the other. So it's a lot of times forensic engineering. And then we all think that static load tests are easy and easily interpretable. But look at Tomlinson, and I think he had to write a page and describe various curves on what are the problems with static load tests and what could have been the problems with the pile with a particular type of curve. So it's not so easy even with the static load tests. And then various failure criteria. Even if you perform a static load test, it's still a challenge to define what is an ultimate load because there are various criteria. So the net result is it's all prone to abuse, misuse, blatant misreporting, because you can't really go and find what is below ground. So let's look at some professional ethics before we come to the academia. Yeah, so this was a case. Well, the contractor reported that the pile was okay and we had to dig 16 meters deep to prove that things were terribly wrong. In fact, 30% of the piles at this project had defects. And this was for a hotel project, which was to be completed before the Commonwealth Games. And the net result was it got completed 2 years after the Commonwealth Games. So the whole purpose of constructing that hotel and the revenues that were going to be generated from it was lost. And why? Because of improper planning, selection of a Tom, Dick and Harry contractor, leading to a lot of losses in terms of financial risk. So this was another case. So this is for a premium railway project. In fact, in this case, the pile was subjected to CSL and reported 4 meters of defect. So the defect was as long as 4 meters. And then it was claimed that it was grouted and repaired and then subsequently tested with a dynamic load test. You could see here that the actual force transfer was 10,000 tons, but when it was analyzed, it went up to 14,900 tons. So a 50% increase in force from what was measured on field to what was used in computation. So, well, it was a blatantly false report. Now, the question is, the contractor is also a technical, has a technical team, has a design team. So what is the responsibility of the main contractor when he submits such a report to the authority for approval? So, is it like a contractor is a postman? He gets the report from the testing company, sends it to the authority. Great. If the authority understands something, it's good. If it doesn't, I'm happy, maybe the pile passes. But what about the structure? Well, that's not a risk for him because probably the liability is for a limited number of years. And then what is the liability of the testing company by submitting such a report? I think we still haven't defined liabilities for blatant abuse or misreporting. So that's something which we need to look at when we talk of professional practice. Similarly, I had some super load test curves because we keep on getting a lot of data, and you could see here, this was for a major project where again the pile was loaded to 54,000 kilonewtons, so 5,400 tons. And you can see this is for a bidirectional load test. So you can see that the load test curve is absolutely flat. So whatever load you apply to the pile, there's no displacement, there's no creep, there's no elastic deformation, nothing. And the same is for the downward, for the bottom plate. Similarly, this was in sand. So at least okay, this was in rock. So I could put an argument saying that, it's so hard rock that nothing moves, but this was in sand and yet the pile did not move. So was it a problem with the load test or was it a problem with the design? So if the designs were so conservative, why do a load test? So yes, I think we all know where the answer lies. Then again, this was another bidirectional load test recently which came to our notice. You could see here that the jack is somewhere like around 2 meters or 3 meters from the bottom. It's in sand. And if you look at the unit friction values, this is above the jack, no friction. And at 20,000 kilonewtons below the jack, no friction. But when you go to the bottom layer, you have 1.1 megapascal or 1180 kilopascals of friction in sand. I am sure probably nobody amongst us would have heard this kind of values. So this was presented by an international company working under a leading and a major contractor. So, I mean, where are we heading? We talk of interaction, we talk of big infrastructure projects, but do we talk of durability? Do we talk of long-term reliability? I think these are things which really need to be addressed in terms of from the academic side, from the industry side. Then this was the mother of all. So we had a premium power project with more than 250 piles for each structure. So cross-hole tests were conducted on all the piles and the reports were submitted as all acceptable piles. So when we did a high-strength dynamic load test, we found a defect. So we reported that. And then further comparison with the cross-hole led to shocking findings. So a full-scale investigation, in fact, led to the findings that out of more than 250 piles, only 70 or 80 were actually fully tested. Another 70 or 80 were partially tested with block pipes or missing scans, and the balance were not tested at all. But all the reports were okay. Now, where is the problem? Okay, maybe the piles were good. So even if they were not tested, maybe they were good. But now, where is the problem? You see, several piles, when the investigation took place, several piles had soft toe conditions, tremie choke, concrete underconsumption. So forget about testing. It was the records that showed serious issues. Now, whose ethics are to be questioned? Is that the testing company? We have a lot of NABL accredited labs these days. So is that a problem with the testing company, with the NABL, or how does the accreditation process takes place? Is that the leading contractor who was also probably hands in glove, or probably the main client who were supposed to be the custodians of the project? Well, I think there are serious questions that need to be answered. So probably the testing agency lost a few lakhs of rupees of pending amount. So it's still operating and free to spoil other projects.
One more minute.
The contractor faces a liability of few crores. Sorry?
One more minute, Ravikant.
Yeah, okay, I'll close it quickly. So in the end, what happens? We all lose money because that's our tax-paid money, and with poor ethics, so we are not going to have sustainable construction towards a better future. So now, quickly summarizing, industry looks at profit and loss with no funding for long-term research. So procurement or purchase departments in the company are stronger than the key technical team. The conclusions will be obvious. Then industry is unwilling to invest into learning, skills, upgradation, or research. Similarly, the academia is unwilling to go to field and collect actual field data and study the outcome. So if you're doing your research on analytical methods or merely on software without validation, then you don't have real data. Similarly, it's high time that academicians invest time and effort to understand all the processes, including testing and instrumentation, and then use it for optimization, design verification, reducing factor of safeties, etc. Well, it's a moral responsibility for all of us to ensure that our structures last long for future generations. And then lastly, I thank IGS, for creating this kind of forums. The industry academia issues are then threadbare discussed. There are bodies like DFI, there are other bodies which are very important forums to share and exchange views and information. So of course, some of the good data is also possible because of good consultants, engineers, testing companies, contractors who believe in responsible engineering. They need to be encouraged and further promoted. Penalties can be a deterrent to poor practices. I'm sure more industry academia interaction will lead to newer and better technologies, products, research, and end outcomes. Thank you, sir, and I hope I have not exceeded my time.
Perfect, Ravi Kiran. Very interesting, very relevant. I could relate to almost all that you said. So now we move on to the next lecture. Sirish, please take over.
Yeah, we have now Professor Murali Krishna from IIT Tirupati. Prior to that, he was at IIT Guwahati. His research interests are on numerical modeling and physical modeling and geotechnical earthquake engineering. So let's see what we have from Dr. Murali Krishna. Over to you, Dr. Murali.
Hi, can you hear me?
Yeah.
Yeah, thank you, Dr. Sirish. And I thank the organizers for inviting me to take part in this very interesting session. I hope you can see my screen, right?
Right. Go ahead, please.
Yeah, great. Yeah, it's very good to hear all previous speakers, particularly the three keynotes what we had from the very experts, stalwarts, Professor Raju, Professor KSR, Professor TGS, really enlightening and covering various things. Of course, many of the things what are there in my thoughts and all, everything they have addressed. So I'm just quickly sharing my views, a quick glimpses, something coming to my thing. As a role of various stakeholders, who are all various stakeholders as far as geotechnical engineering practice concerned? Of course, in India, what are the problems? Already earlier speakers have highlighted. So what could be roles for these stakeholders? I just quickly share. Okay. So I'm just taking a slide from Professor Shivkugan just to explain any geotechnical project, what and all it encompasses. Okay, initial planning to execute some project, and then doing some site investigation and getting the samples and laboratory testing, and obtain the soil parameters and design office, design analysis and implementation. These are various stages. And in each of these stages, what are the people involved, or I'm counting them as the stakeholders, various stakeholders, starting from the client to the executor, finally contractor, in between various other people are involved in that one. So everybody had to play their role, particularly for a successful project. Of course, our focus currently is to pay attention to geotechnical related aspects. How a structure should be effective and safe, performing its function, satisfying the geotechnical requirements. That's what our focus. So among these various activities, geotechnical quality geotechnical investigation is a prerequisite, as we all know. Everybody is highlighted, and where geotechnical engineering specialists is very, very important for this successful project. When I say geotechnical engineering specialists, like what we are talking about, academician and practitioner, both are having equal role in performing their respective roles. We have to see. That's where we have to sensitize to go ahead, how to improve the geotechnical engineering practice in India. Because earlier speakers, they mentioned, right? Elsewhere in the globe, other countries, they are very well practicing the geotechnical engineering aspects, starting from the testing and design and implementation, execution, even for the observational method of construction, the design, etc., and so on. All the every people have their own roles. And another point to note, and which we need to sensitize across all the stakeholders, is the reason for failure of several structures, okay, which are due to improper geotechnical investigation and the consideration. The effects needs to be sensitized effectively across all different people. So as part of the thing. And of course, some important aspects of geotechnical investigation, which I need not to tell again. For effective design of this project, economical design of the project, of course, investigation is required, proper investigation, and we can avoid the project delays, soil failures can be avoided. And like previous speakers also mentioned, no, once you construct the foundations, you need not to alter or modify, improve the things, all those things we have to see. So it should be investigation should be the part of the design process, and we have to maintain the optimum level of investigation, at the same time maintaining the total project cost. Generally, when you look into the cost of the investigation on geotechnical aspects, no, it will be like about 0.5 to 1%, up to 2% it may go for entire project cost. This aspect need to be sensitized to all the clients, all the practicing bodies, whatever the government bodies, private consultant, client. So that should be emphasized effectively, and they have to pay proper attention to the geotechnical aspects. In this regard, I like this slide which was presented by this professor, which is showing the cost of investigation, how much we'll be spending, and how we can optimize the total project cost. So these graphs will show even a very challenging site, what level of site investigation amounts we have to spend, and in a very benign site, how much we have to spend, and these things. So these are very, very interesting and encouraging results, no, which makes the people client to spend some significant amount of amount for the geotechnical investigation, the concern, and so that total project cost can be minimized. These aspects need to be assured. And particularly geotechnical understanding at site before the ground investigation, if we have before the design and construction aspect, if we have sufficiently, then total cost of the structure, cost of the whole project can be minimized. So this is another good example showing the importance of geotechnical investigation and its aspects taking into consideration in terms of design during the construction and so on, so that in the service condition we have to avoid the problem. This is some interesting course. And when we talk about the cost of site investigation, there's the data what is available. Of course, different projects, different places, different percentage of money involved. But overall, if you see, mostly in the even many of the projects, no, it will be costing up to 2% in the normal condition, and only particularly when we deal with the type structures, dams and other things, it will be shooting a little bit more. Otherwise, it will be within the 2%. So, which is what the amount we have to look into things. Now, looking into various stakeholders, what I'm trying to highlight. So, starting from the client, who is the particular person who will be handling any project. Okay, he should know their role in addressing and taking sufficient care of geotechnical consideration. And then comes to the geotechnical practitioners. When you say geotechnical practitioners, various level will be there. Investigation agencies, particularly who are really conducting the field testing and giving the soil parameters. And of course, when we talk about agencies and the accreditation authorities also, accreditation authorities also, they should be the process, okay, enable accreditation or some agency accreditation when we are giving to a particular agency, it should be very carefully doing that particular process. That's an important role. And the designers taking into geotechnical parameters and how they will evaluate the project, that's very important. And then of course, contractors during the execution, many of the times they are not paying proper attention to the geotechnical aspects. For example, they will go for the deep excavations without giving the proper support. And while doing the construction, they will not pay attention what type of faults they are getting, what could be the problems anticipated. Okay, those sort of observations are many times they are missing. They also need to pay proper attention. And then, of course, very importantly, the local governing bodies and departments. So they have the very significant role to form the stringent rule. Okay, they have to properly emphasize the requirement of proper geotechnical investigation and the quality investigation. They have to establish the stringent rules. For example,
Dr. Murali Krishna, 1 minute, please.
Yeah, I will be done. Example of high-speed rail project, if you see in Ahmedabad, you see a very huge geotechnical laboratory they have built, and they are doing very high-quality investigation because the particular project following the Japanese codes and standards and very stringent rule they are following, it is being implemented. So when there is strict rule is there, the proper consideration is very good. And of course, academicians, which will be preparing, various other practitioners and academicians, they are developing, and they have to take active role with the interaction with various other stakeholders. We have to see, and just roles and discussion points, something like I mentioned here. So academicians should do needful to inculcate the ethics to various stakeholders, like either upcoming practitioners and academicians, and they should encourage the entrepreneurs. As a geotechnical people should be entering into the field, as somebody mentioned, no, non-geotechnical, non-engineer person, if he is there in the field, they will look the business as a money oriented, whereas technical people will look into a different perspective. So we are seeing real examples, and they should encourage more practical training and exposure to students, and outreach program should be conducted, particularly sensitizing the clients and practitioners, local governing bodies. And Professor Amit Prashant mentioned IRC guidelines have been evolved by looking into practical considerations, where the academician and practitioner interaction, all those things should be happening more frequently. And particularly their role in the finding, research findings and novel approaches should be developing. And particularly the point of the cost of investigation is very important. Now, of course, Mr. Ravi Sundaram has highlighted the L1 criteria. L1 criteria, if somebody want to grab the project, they have to be L1. So with this objective, they are putting very minimal cost without properly looking into the amount to be included. I wonder these private practicing agencies should be, as a country, they should be forming as a group or consortium, or as a group. They have to fix the minimum rates for doing certain investigation. Okay, this level of investigation, this rates should be there, and more or less it should.
Dr. Murali, kindly conclude, please.
Yeah, I'm concluding. That is an point to be noted, and we have to note what's the time required for various steps, and also we have to establish the healthy competition among the practitioners. That's one thing. So which is to be adopted. In all these things, there has a proper interaction between academicians and practitioners is very important. Yeah, these are my quick thoughts. Thank you for the time. Thank you.
Yeah, thank you, Murali, for sharing your thoughts and points. We'll discuss at the end. Over to Dr. Pichmani.
Yeah, thank you, Suresh. Next, we move on to the industry side. We have Dr. C.R. Parthasarathi. So he is the Sarathi of Sarathi Geotech. He is driving it along. So all of us know him. He's a PhD from IISc. So he's running his company for quite some time now, and since 2007. So let us invite Dr. Parthasarathi to share his views. Welcome, Dr. Parthasarathi. You are on mute, Dr. Parthsarathi.
Sorry about it.
Yes.
Yeah, sorry about it.
You have to start all over again.
Yeah, thank you, sir. Thank you for this nice introduction. And at the outset, I thank the organizers for giving me an opportunity to share some perspective on today's topic on the academia industry's perspective in reference to the geotechnical engineering practice. Today, I will focus on the training needs for future geotechnical engineers. I think the previous speaker, all of them have nicely elucidated the need of quality geotechnical investigations and the works and to the reference to the requirement of future needs in the country. As we all know that the national infrastructure pipeline from the government of India has said there's going to be an investment of nearly 1.5 trillion US dollar over the next decade. It's just 5 years, probably the next 10 years as well. So therefore, there's going to be a huge development in the infrastructure. I think Professor Sitaram has highlighted many big projects and also previous speakers. So do we have enough capacity to meet this drastic growth? I don't think so we have in the country. We have 30,000 geotechnical, civil engineers being graduated every year. Okay, and the quality of the engineers coming out of school, I think most of them are nearly 60–70% of them are not employable directly. Today, there is abundance of knowledge available, but what is lacking is the skill. So knowledge is free, unlike our times 25 years before, we don't have access to information, but today it is available for free. And these young kids requires really the skill for them to be ready for the accelerated growth. So it built for 50 years, but today we are talking about 5–6 years of the similar or alternate structures. Likewise, the infrastructures are all time-bound structures. So safety or failure is one part of it, but most of the times we see that there's a cost overrun and the time overrun because of lack of knowledge in the basic thing that we need to do on the project sites. So there are many opportunities exist for geotechnical engineering. They can actually focus on several industry, the oil and gas industry, the railway infrastructure is booming, marine infrastructure, India being the peninsula, I think all the coasts are being developed. Real estate, I think there's going to be a huge potential for people to go into the real estate sector. Renewable energy, the onshore wind has been very popular in the country, and offshore for the next decade, offshore wind also is going to come up in a big way. Mining industry, these are some of the sectors that people can opt for. I'll skip that academic part of it. As we all know, length and breadth of the country has different geologies. Okay, the Deccan Plateau has different stratigraphy, the overburden, the weathered rock and refusal stratum. As you go along the coast, we see deep-seated soft clays about 30 meters to 40 meters, followed by alternate layers of very stiff and sand. On the top, the alluvial deposits, and you see the black cotton soil. Does one size, one procedures fits for all the geography? Probably not. Okay, so therefore, we always advocate an integrated approach of site survey, performing a geophysical or a geological investigation, identifying those geohazards, and develop the scope of geotechnical investigation, comprising both the field test as well as the laboratory test. This becomes a part of any of the infrastructures. That is the basic step to characterize the ground. Okay. Now, several in situ tests, that is in practice, SPT has been spoken at length. I'll just share a couple of slides with energy measurement. CPT has not been very popular in the country, although there are some projects commission these CPTs, in situ vein, pressure meter, and dilatometer. So what are we lacking in the site characterization? What are we lacking today is the understanding of the basic things that the engineer on the ground has to understand. So when you talk about the energy measurement, Professor Raju nicely showed that there are several practices in the country not in compliance with the international standards. Yes, that is the case. Slowly we need to transform. When we started accumulating the energy transfer onto several driving systems, the rotary rig, the calyx types, the auto trip hammers, and the multi-purpose drilling rig, we notice that the auto trip hammers relatively has a consistent about 55 to 65% of energy transfers, provided you have all the rest of the things right, that alignment of the rod, verticality, the anvil close to the ground, and so on and so forth. But consistently, the donut drop with the rope has very less energy transfer, but we pick up these measured N values from this driving system and then use that for our assessment. All of the geotechnical derives from these N values. Sometimes you are overestimating, sometimes you are underestimating. So therefore, it becomes imperative for us to know what is the energy transfer to that particular rig. It has to be calibrated periodically, and so that you can standardize to a certain value, for example, N60. So when we talk about the soil sampling, so how are we collecting soil samples today? Invariably with these SPT hammers, we are driving these Shelby tubes or the open-ended pipe tubes. But the best practice is to push them into the ground and collect samples. This is a common practice in offshore. We do for every meter of sample that is recovered. We extrude the sample in real time, test it for undrained shear strength, and then you pack remaining samples nicely for further testing in the onshore laboratory. But that practice has never been in the onshore space. Probably we need to move towards that practice. So try to implement the mobile labs, which has a containerized equipment, which you can have the real-time measurement of the water content, unit weight, undrained shear strength, and the quality of samples can be viewed. You can take the pictures of the samples. So in 24 hours, the end of the borehole completion, you already have a bore log ready that can be relayed in real time using various apps. Today, the technology is there. I think we need to take advantage. So I'll just illustrate one example of not performing a good shear strength. No, you see the tar vein. The red one is the mini vein, and the lower bound is all the UU triaxial test results. So compared to the other test methods, this is giving a very low values of soft clays. So when you have this kind of variability in the measured shear strength, you will have to make an assessment of foundation. This is a jack-up leg foundation, which shows you an uncontrollable leg penetration. So when we introspect, why is this big difference? We came to know that the measurement was wrong.
2 minutes.
Yes, sir. Measurement was wrong, and therefore, by re-investigation, the CPTs and the undrained shear strength were all in alignment. So what is lacking there is the knowledge of testing was lacking. The minimum things was lacking for the engineer on the ground. So therefore, the doctors carry stethoscope, the barbers carry the knife and the razors. I think we geotechnical need to carry a small pocket spectrometer and the tar vein onto the ground to collect the samples. Okay. So the deep foundation testing as well. So when we talk about the information, if we do not have the understanding of the technology, we'll end up having reporting the measured capacities. But when you actually look at the data, it doesn't match your requirement, the total skin friction, total capacity to the sum of the end bearing and the skin friction. Or against, when you look at the data, you do not have the capacity, but it is reported to have achieved. So why is this required? Why is this happening? Because there's a lack of knowledge of people and the skill is not there. So training becomes imperative. So in addition to the geotechnical, my last slide, we need to also think of imparting some additional skill sets to people for building their entrepreneur skills, also to get some kind of understanding on the management, the sales, marketing, operations, finance, and HR. So they will also have a very good working knowledge to be collaborative with many other stakeholders in the project. In summary, there are plenty of opportunities. The mismatch of capacity and demand is there. We need to build that by skill development to training and certification, implement newer technology at affordable cost, and industry and academia can work together to meet the above objectives. With this, thank you for the time. I'll be happy to take any questions. Thank you, sir.
Thank you, Dr. Parthsarthi. Interesting lecture. Sirish?
Yeah, so now we have one more presentation from academia side. Dr. Neelima Satyam, she's associate professor at IIT Indore. She's head of the department right now, and she, her research interest lies in earthquake geotechnical engineering as well as landslide technology. So let's move on to the next presentation. Dr. Neelima. Yeah, I think there is a problem from her side. Maybe we can take the industry first. She's calling me on my other phone. So, Dr. Pichman.
Yeah,
I can finish the industry lecture, then we can come.
Okay, then let us have Vetrichelvan give his lecture, and then we'll go ahead with Nilima. So Vetrichelvan is from L&T. He was in Keller earlier, so he heads the technology department of L&T Geostructures. So he's a bachelor's in civil engineering from Madras University, and then this thing MTech Geotech from Anna University, Guindy. So let us hear from him what he has to say from the industry point of view. Welcome, Vetrichelvan.
Thanks, Dr. Kumar Pichmani. First of all, I'll take this time to thank Professor Muthukumaran for giving this opportunity and also the organizers. I'll talk about the challenges in deep excavation. It's more of my own introspection about the deep excavation techniques, what we have practiced. My topics consist of, I'll be talking about the deep excavation system, which has been practiced in India, and the supporting system, which has been used for the deep excavation. And I talk about the typical loading considered in the design of deep excavation. What are the analysis, how we are doing it normally, and thought for discussion. That's what the flow of my presentation. Of course, everyone knows that there are different methods have been used to retain the soil in India. That is soldier pile wall, sheet pile wall, continuous port pile wall, second pile wall, which is very not much common, but it's also happening. And of course, diaphragm wall. I think that the deep excavation has become very important in Indian scenario because of the urbanization and a lot of congestion in the urban area. Due to that, I think deep excavation become very common nowadays. Maybe in the last 10 to 20 years, I think it's become very much relevant. And also due to the metro activities happening throughout the country, I think this has become very relevant to us. And in future, I think this is going to be more relevant, and more deep excavation is going to happen. I think everyone want to utilize the area much more compared to what is available. They want to utilize the urban area much efficiently. So instead of going up, they want to go down also and try to utilize the space much more. When I look into the different supporting systems, like anchors, one of the supporting system, a strut is one of the supporting system, and top-down method is also one of the supporting system for the retaining structure. If I'm looking into the anchors, I think even though we are having a design of rock anchors, but still, if I look into it, we don't have any code or any procedures for the soil anchor design of soil anchors. Still, we are going with DS or we are going with the FSWA for reference, and we are doing the design. There's one of the things I thought that even though we are doing a lot of designs, it can be standardized. So one of the thought it came to me, so I thought I want to share this with the academician and all the highly knowledgeable people here. When I see the excavation supporting system, there are a lot of systems we are talking about it. Sheet piles, continuous pile, as I mentioned before. There are typically where it can be used and what are the verticality conditions it can be constructed, and whether it can be used in the groundwater control temporary case or permanent case. If you can see, there are a lot of classification it has been. I have taken this from Syria manual, one of the nice manuals. This specific petition of this manual is 580. That's one of the I think most sold Syria manual in the world. You can see the embedment retaining wall design. This is a new one. If you see that in this, actually, if you see best possible or typical verticality of the continuous pile wall is 1:75, or it can go up to 1:125. Whereas if you are going for a diaphragm wall, even it can go up to 1:200 or 1:400 is possible. That is the verticality we can able to maintain it, because verticality is one of the important factor in the retaining wall design. But whereas in Indian codes, still we are going with 1:67 is typically for the it's mainly for the vertical pile design, normal pile design, whereas it has not been specifically for the retaining system. Similarly, if you see the diaphragm wall, even though it is for the retaining system, still the verticality has been specified as 1:80. Just to have a thought, maybe we need to upgrade it or we need to change it to suit the present condition, and so that already the equipments are in place. And in India, and everyone is utilizing it. Even I think metros we are doing at 1:1 and 200 verticality. That is what we are practicing it. So we may need to think that we may need to upgrade this, especially for the excavation support system maybe. If I see the force acting on the wall, it's a typical cantilever wall. It's what type of surcharge normally we'll consider. What is the surcharge I need to consider for a design? Where I have to find this, I think we will go to VS Code for temporary case, and maybe we are going to IRC for permanent case, but still we don't have specifically what need to be used for the design. That maybe we need to we need to devise it, and we may need to put it in a guideline so that everyone can practice it or use it uniformly. That will help us. And similarly, in urban scenario, mostly we will be working in a very congested area. Maybe the crane will be running very close to the wall or a retaining system. How to use how to consider the complete force is going to come to this wall. Of course, there are literatures are there. I'm not saying that literature are there. International practice is there. We can go to BS, or we can go to other papers. But it may be standardized. It will be more uniformity will be there in the design. The consistency will be there in the approach of the practicing engineers. Similarly, if I'm seeing the active pressure, if it is a cantilever wall, active pressure is fine. Whenever it is going for a with struts or with floor supports, this active pressure, how much I have to consider for the long-term behavior. That is going to be one of the things. Mostly, it goes from KA to KA naught. That is what we are practicing in all the metros. So that need to be also be spread to everyone. That message need to be there everywhere. Similarly, if I'm seeing the water pressure, when I want to do the analysis for a temporary case, how I'm going to analyze it, whether I want to consider a balancing of water pressure from the both sides or not. Depending upon the soil condition, I need to do that. That has been spelled out in, I think, in Seria, but I think we don't have any code or any procedure to spell out that. So if I'm similarly for the seismic pressure, there is a coefficient we have considered. But of course, this behavior also is going to be different when I'm having a rigid structure. This behavior is also going to be different. This also not being addressed in our codes. So when I'm going through my previous design, I can see that a lot of things we have referred to other international practice and other places, but maybe it may be the time for us now to look into what need to be done to our localized or customized for our Indian conditions. Of course, you will have a net pressure, you will design the wall, but if you have a strut, the behavior will be completely different, and the things need to be completely thought differently. Of course, we as a academician, what we are, as a practitioner, what we are doing is we use a spreadsheet for calculation, or we're also using pseudo analysis like VALAP. Mostly VALAP have been used. Some cases, for special cases, we are using Plaxis, 2D or 3D, or other finite element softwares. Of course, we are using it, but we don't have any sort of each. If you analyze by the VALAP or Plaxis, there are some variations will be there in the result. Of course, it's not going to be major, but there is a possibility that some variation will be there. Maybe we need to go for some sort of guidelines also for this, how to address this. Then the main thing is the serviceability. When I'm using a different type of supporting system, say for example, if you want to use an anchor, how the wall is going to behave. When you're going to use a strut, how it's going to behave, how much it is going to have a deflection horizontally as well as vertically, and how this is going to affect my structures nearby. This all need to be also be addressed, because when you do lot of cases, a lot of issues happen on the vertical displacement. Lot of issues have been happened, especially when you're doing in urban area. Maybe we need to look. I think in metros, I think extensively they are using standards to monitor it, and everything has been done. But for a common excavation, deep excavation, this need to be spread throughout the country, and the message has to be spread to everyone so that it can be practiced. Everyone can practice it. So this is also one of the.
1 minute.
Yeah, it will be done in 1 minute, no problem. My last slide. So when I see that what thoughts for discussion, maybe we need to have a clear guidelines for Indian scenario, especially for what type of fitting system I'm going to use it, and where I have to use what. And also I have to see the serviceability condition, what type of loading details I need to consider, what are the instrumentation monitoring I need to follow it up. A lot of things can be a guideline and it can be implemented. I think Dr. Kumar Pichmani is extensively spreading the message, but I think it need to be created as a documentation that will be useful. Thank you.
Thank you, Vetri.
Yeah.
Yeah, thank you. I think Neelima could join on the other phone. Dr. Neelima?
Yeah, 1 second.
Yeah. Can you please share your screen?
Sorry, actually, somehow my laptop has gone wrong suddenly. So can I start?
Yeah, please go ahead.
So my screen is visible, right?
Yes, go ahead.
Okay. So first of all, good evening, everyone. I'm sorry for some technical issue in my office so suddenly. So my topic, first of all, I should extend my sincere thanks for the organizing team for giving me this opportunity to share some of my ideas, I can say, or like to discuss or exchange some of the ideas or my experiences, especially with the landslide hazard. I slightly changed my topic to landslide hazard management because we are doing a lot of forecasting, mapping, monitoring, and of course mitigation. But I think that till mitigation, I think this is not sufficient for us. We have to add some of the socio-economical aspects when we really want to take resilient infrastructure. So this is my topic for today's panel discussion. And we know that landslides are second common disasters after flood and earthquakes, and more than 15% of our Indian landmass is completely vulnerable to this particular disaster. Not only in the Himalayan region, which is maybe prone for both because of rainfall induced and seismically or co-seismic, I can say, we have huge casualties or the disaster. The scale is much higher in Western Ghats and also parts of Eastern Ghats. And if you look at this annually, so 2011 estimate, it suggests that India just suffered almost like 200 crores INR every year from this disaster, and this is as per NADM, and it is increasing every year. So, and a lot of cascading effects are also coming, and according to the global inventory on landslides, which has been published in 2016, India accounts for highest, that is 28% construction triggered landslides, followed by China and Pakistan, which are of 9% and 6% respectively. So I just put it slightly different here because as we see that, not only as Western Ghats, Eastern Ghats, and Himalayan region, which are highly prone to landslide disaster, the climate change and extreme events are becoming very, very common. I can say frequency has been increased. For that, we just not need to stop till mitigation part. We need to build a system, or we need to come up with approaches wherein like our infrastructure can adapt to these climate changes, and so that we can build a resilient infrastructure. So in addition to these extreme events, we also have issues because of construction, or I can say unengineered way, mining, hill cutting, or also adding some of the issues, so that this increasing number of landslides we are seeing. And so that we need to build in short-term and long-term mitigation approaches, so that the management strategies to keep the secondary effect and loss can be minimized. So I just call it as a slope safety system, which we need to build it up. It's not just about mapping, it's more about building a warning system, incorporating all the stakeholders of government, construction agencies, public, and also with proper public outreach. So if you see this particular slide, like where infrastructure development has happened since independence, I can say, especially for the development of hill towns in the country since 1947. So huge amount of development because of population increase, population migration is another challenge now for us, and urbanization. And these construction activities along the hill slopes have obviously affected the stability and the analysis of the global data, which has been published in 2016, which says that we are having high percentage of construction triggered landslides in the world. when we look at the factors, so we can primarily do type of factors like preparatory factors and triggering factors, or we can divide into two sets. So wherein like these primary factors or characteristics of the landscape which remain unchanged or vary very little from the human perspective, but in the present scenario, rapid urbanization, especially in the mountain regions, is resulting in topographic changes. It is such a highly dynamic change at present. The signatures of the ground have been changed, and these data has to be updated regularly. This kind of data is not even there with the public administrations, so that we can come up with a proper solution or planning when we are doing a larger infrastructure projects. Due to this lack of long-term records which are relating to landslide activity, to historic earthquakes or like floods or any other initiating factors, the permanent factors are usually used to estimate the landslide hazards. So landslide is a highly complex problem. It's not only the spatial factors, we also have a lot of temporal factors, because rainfall and seismic activities can trigger a slide and independently, and they can both have a combined effect. As we are seeing, we have another site. Joshimath, wherein like recently in the sense this year February, we had a major disaster in the Joshimath region. So we are having a project from DST where we are monitoring, real-time monitoring of both seismic, microseismic monitoring, and also the rainfall induced lights. We are doing that. We just started that. And in a marginally stable condition, the permanent factors are favorable for the occurrence of the landslides, but the occurrence of the triggering factors can result in reducing the factor of safety less than 1. So when we see the hazard zonation maps, because we do have a lot of susceptibility maps, but when we see that in the parts of Kerala, Western Ghats, in 2018, whatever the available susceptibility maps were like, highly susceptible areas, we could not see any slide, but whereas like not so susceptible, we had huge amount of debris slides has been observed. So there is a lot of, we need to build the maps of the different scales, project scale, local scale, and regional scales. So because during failure, the falling mass can be classified either two, right? Source area and the runout area, because landslide is a generic term where we need to, we will have debris slides also, which are very common in the Western Ghats, wherein like the runout distance was almost like 3.5 kilometers. And the source area is very critical slip surface, which least factor of safety, which falls on the onset of the triggering factor. In the case of shallow slides, the failed mass remain at the toe, but in the case of rockfall or debris, it can travel for a very, very long distance. I'll just give you one of the example where we have done for the Kuchimala debris slide, and that I'll show you in the next slide. So coming to the, in terms of infrastructure projects, we need to, of course, all my previous speakers, which eminent speakers, or everybody shared their views. So I don't have much related to that, but I can just add a little bit. So almost all major slides should be investigated in detail for understanding the subsurface profiles and topographic changes. And it should reflect in the database, because ignoring the spatial variability may underestimate the probability of the failure. So that proper investigation and slope safety analysis before starting each project is something very crucial. This is the investigation which we have done in the debris slide, and it was almost like 3 kilometers starting from a very forest region to the some urban habitat region in Kerala.
Nilima,
of course, I should acknowledge Dr. Anil Joseph for this. So coming to our analysis, we have deterministic approach, but of course we do have uncertainties. In the probabilistic approaches which we have for the slope stability, it won't consider the effect of vegetation and climatic factors. So we have to move towards a data-driven or AI-based or ML-based techniques which we already have it. So this is one of our analysis, wherein like we use different ML techniques like logistic regression, KNN, random forest, support vector mission, so that we can see which model will fit in based upon the training the data. So I'll just quickly skip some of the things. These are so coming to the monitoring aspect. So these are some of, we started
Nilima,
real-time monitoring.
can you please quickly wrap up?
Yeah, I'll finish it up. Just give me 2 minutes.
Thanks. Yeah, thank you.
So in the real-time monitoring, we have been doing the real-time monitoring since last 4.5 years in an area called Kalimpong, which is highly rainfall-induced slide. So this is some of the things wherein like we are not doing the monitoring for a larger area because it is highly uneconomical. We are doing the monitoring to validate our forecasting model so that we can forecast the landslides. So coming to the runout modeling, we do have a lot of techniques, and this is one of our site like Kuchimala debris site in the Western Ghats, where we have done complete modeling using a commercial software RAMs, and then of course we have done the back analysis for the values of mu and psi, so that we can predict the entrainment, etc. So because the model has, only, it is not a generalized model. So we got support from ISRO, and wherein we developed a numerical model which is more generalized. So this is DFS code. So this is, I mean, anybody can use it if they have a DEM as an input. It can give you the track along with the entrainment and velocity, and all the heat maps will be generated. And this particular code is also validated with different examples from China and Italy. This is one example from South China. So coming to the landslide risk reduction, so unstable slopes need to be stabilized. I'm not going to detail because NDMA has given very clear guidelines about how to handle this, where to avoid and where to start the construction activities. So, and coming to the stabilization part, sharing data is a new key for risk reduction. Before starting any project, its impact and slope stability should be properly analyzed in detail. Any modification in the drainage channel by any agency should be properly, somewhere it should be noted with the public administration, so that that can be used and properly mapped for the hazard and the risk. So, and in addition to that, we do have different techniques. I think
Nilima, can you please wrap up?
Sridevi explained about the GPS thing. In addition to that, we do have a lot of ground-based models, which we are also into using that. And then I'll just skip this slide because of this, so that I can finish it off. So this is my last slide. So in addition to that, I just want to bring it. We have standards like codes are there, IS codes are there. In addition to IS codes, we do have IRC, RDSO, and Ministry of Railways codes are there for guidelines for construction, especially in the mountain and the hilly areas. But what are the practice? I think this is the important point. This is some of the views of the BRO with whom we are working at Joshimat right now. So they feel that proper and precise mapping at a required scale is not there with us. Actual data details and its effect on the during heavy rain, and of course in these such areas after rain snow follows. So that means like we have a very huge rapid and recurring slides, and then mitigation is now like a trial and hit, and very limited experience and knowledge, especially with the manpower in the investigation agencies. But it may be good with the geotechnical, but for this kind of problems we need a very strong geological, hydrological. Landslide hydrology is one of the very key thing to understand the physics behind this disaster or hazard, and for that we need a lot of in situ monitoring and field investigations. So solution, proper land use planning, and to very dynamic capturing the dynamic signatures of the ground, setting the geotechnical standards, improvising the existing slopes, public education and outreach promotion. With this, I'll thank everyone for your patient listening, and sorry for my swapping of the time. Thanks.
Thanks, Nilima. Yeah, it's a good presentation. Let's move on now. Now we have heard about almost 13 presentations and without any break. So, and we try to collect questions from the other side, like from visual platform. But there are no, important questions from the other side. So we can start our presentation and discussion. So we have a couple of questions we have framed from the existing presentations, and probably we can request the chair of each team, like academia team and industry team, and the questions can be addressed one after the other probably. Is that fine? Any suggestions going further? It's also welcome. Dr. Kumar?
One question for Dr. Sridevi, can I ask?
Yeah. Shall we do that? It's not like a question answer session, but yeah, you can ask the question like if the...
Yeah, it is not a question. It's just an appreciation what Dr. Sridevi has done. Dr. Sridevi, are you doing a study for rainfall-induced landslides also?
See, that one landslide we monitored, I think for 7 years. So we had rainfall measurements also, along with all the instrumentation, full geotechnical instrumentation, all real time. We even constructed a small room from where the data was sent to Central Building Research Institute, Roorkee. So that time we did even rainfall integration and all. That was published as a book actually.
Yeah, that book actually I may be interested to have, but I will send you the mail. Okay.
Yeah. Sridevi at CSIR Korpai is my mail.
Okay. Thank you, Sridevi.
Yeah, Dr. Kumar Pichmani, can you please start some questions so that we can proceed further?
good
We also
evening.
have, one second, sorry to disturb you. We have special invitees also from industry. We have Dr. Akshay Jha from South Central Railways. He's a chief engineer, chief track engineer. And also we have Miss Dola Rai Chaudhary in the panel. She's also like eminent geotechnical engineer and founder and director for GQ Engineering Services, consulting engineers. So welcome, and I think we can start the discussion, please. Thank you.
Okay, good evening. So what we plan to do is whatever question is raised, it will be raised to each of these committees. So the chairman will take the question, and then the answer can be given by the chairman or with the help of any of the members of the committee, or ask any of the members to reply depending on their experience. So from the industry side, okay, as far as I can put it, see, Deepankar Chaudhary mentioned a very interesting point that one has to love his work. So the question is, how could there is a question that is raised that the industry needs multidisciplinary skills. So at the entry level, what the industry often ends up is not skill sets, but carefully researched keywords on the CV. Now with this, how do you make the students love the subject, or how should the industry proceed to make the students love the subject, or the other way around? Can this this is an interesting question, because I haven't heard such a question earlier. This has been raised by Dola Rai Chaudhary. Can the academia or Deepankar himself tell about how this could be done?
Yeah, so essentially, see, it is a chicken and egg problem, whichever comes first. So if I say from that angle, first of all, one has to start studying geotechnics, of course, in academia. And then if they find it interesting by themselves, then probably they will further proceed. It's like in the life also, we select certain profession, certain subject, certain area, if we like it, isn't it? Otherwise, it becomes a forced one. So same thing happens for geotechnics also. Same with the industry. Like obviously, somebody on the first day joining industry, we don't expect him or her to execute at the field level. Through process, through mentoring. So here mentoring takes a very important role actually in industry, because as I said, in academia, probably people can still do a mistake, but in industry, probably that will be a more disastrous. So that's why I wanted to mention that if somebody is not having a love or liking for the subject, it cannot be forced, or it should not be pursued actually. So better to do or change the area and do something better where they find it interesting. That's all I can say. It's, of course, it is a trial and error process. There is no such prescribed medicine that, okay, take this medicine and you will start loving the geotechnics. It's not like that. That is what I can say.
Yeah, very nice. Thank you, Deepankar. From the industry side, answers, any views, any thoughts? Yeah, KSR.
I think from Deep Foundation Institute, we have started the student outreach. I think Professor Amit Prashant knows this very well. We wanted to create some kind of an interest among the students about the geotechnical engineering, the challenges, and how interesting is the subject for a field engineer. We are trying to do that so that, Professor Deepankar says, you join if you like it. If you like a challenging engineering, you come to geotechnical engineering. So this is the kind of message we want to try to do. I think Amit Prashant is doing a lot of work on this, along with our DP Prasad. Yeah, I think that's one way is to show them what is there in the field. That is one way. On their own, to get to like geotechnical engineering is very difficult. Yeah, that's my answer.
Kumar, Raju here, if there is time, I just have some thoughts.
Sure, Dr. Raju.
Sure, sir, please.
Yeah, actually, we can look at different models. So very quickly, some of you know this German model. In Germany, nobody becomes a professor before he works in industry for a couple of years. You get your doctorate, and then go out to the industry, work for some years, and then you're invited to become a chair professor. That is a fantastic model, which of course not easy to implement. Number two is, in Germany, nobody is allowed to do a PhD before he has sufficient exposure to the field. See, what is happening with our academics right now, I believe, is that, somebody joins for PhD. This applies to me also as a young assistant professor. Somebody is busy making PhDs or producing PhDs so that he can become an associate professor and then a professor. Then, a lot of it is lost. Hardly these people know anything about the practice before they get a PhD. Then they sit on a high pedestal, so they don't want to learn off. Because I'm a PhD, I know everything. So they are not able to interact with the industry. So very quickly to summarize, what I feel is, as academics, especially, like Sitaram, who is now our director, we should slightly change the requirements for promotions in the academic system. We should give equal weightage to both field involvement and field experience as well as for research. In fact, in geotechnical, I would say you give more importance to the exposure to the practice. Then when we teach, we should not take examples from textbooks. You have to take examples either from your own experience or go and study the Indian experience and Indian examples. So that makes it very interesting. Also make it compulsory for the students to have internship. Starting at bachelor's level, they must all go to the industry. And finally, I'll conclude because otherwise it can go on and go on. But maybe I'll send a note on that. But what can also be done is that, even academics, even though they have a PhD, they should spend a month every summer somewhere, either on the work site, or work with consulting, very highly evolved geotechnical consulting agencies, which are of course very few in the country, and keep learning. Even today, at the age of 81, when I take up a project, I'm learning something new. So therefore, there is so much to be learned. So that's all I would like to say. Thank you.
Thank you, Professor V.S. Raju. Very interesting viewpoints from Ramakrishna and Professor and Deepankar Chaudhary. Now, from the industry side, I have quite a few questions which I would like to raise. So first thing is, the hill roads are being widened. All the NHAI roads, 2-lane roads along the hills are being widened to 4 lanes. But there is no infrastructure, there is no design. NHAI is involved in this. So in some way or the other, there has to be some interaction with the geotech fraternity while the DPR is being prepared. Most of the times these DPRs are prepared by some consultant, and then there is no emphasis given on everything goes on ROW. So there's no emphasis given on how good or how bad the rocks are. I know all of you know how bad how poor or how new the Himalayan geology is. So this is one point which needs to be looked into. Any viewpoints from the academia and the industry? I would rather like academia to give some points on this.
Yeah, can I come in?
Sure.
Thank you. You see, geotechnical engineering itself in civil engineering is actually put at the back burner. Not much training goes on in the undergraduate level. And because of that, many times, the people who prepare these kind of DPRs would not be knowing much of really a challenge. They will only come to running to an expert when there is a serious problem. That means when there is a failure occurs or anything collapses, then they will look for a geotechnical consultant. Till that, I haven't seen really seriously discussing with geotechnical expertise. And I think this needs to change. This should change. And I think in large projects, slowly it is coming up because as I told you, as you go approach investigations and design are interlinked. So in those cases, they are interacting, and then we hope for the best. But the things have to change. But widening the roads and is an issue. Today we know the solutions. It's not that it cannot be done, but there's no willpower to do that at the project level. Only they will come to you when there is a serious issue. Till that, they would like to solve themselves, like bearing capacity problem. They will simply take some number and work with it.
Professor Sitaram, I am saying, how does the academia enter into all this and try to change the mindset of the government? That is of main concern. Nilima, I think you have raised your hand. You have anything to say?
Sir, just I have only one point. I think that I mentioned in my last slide also. Because of time, I could not discuss much. Sir, Ministry of Finance revised the format, for Expenditure Finance Committee, that is EPC, EFC, and detailed project report also to include the disaster management concerns. There was a circular on this as well. So it states that, while framing this EFC memo and respect to DPRs, a set of questions have been framed. So wherein, I think your question to get involvement of academia, I think there is a scope. So that's all. Thank you.
Right. Thank you. From the industry, any viewpoints? How this could be tackled?
I think
I have to say, okay.
Okay, Sridevi, please go ahead.
No, it's okay.
No, please. I think you made a very interesting presentation. I think please go ahead.
Yeah, Sridevi, go ahead. Yes.
There are two things involved there. One is, I have done fieldwork extensively in the border areas of Himalayas. As recently as July, I went to Ladakh. The problem is, it's not only the ecology is disturbed, not only because this is not related to this, but I thought I should tell the audience because it's not just we doing it. The other country also does. They also flout all norms and rules. And we not populating border areas is becoming a security issue for the government. And as far as academia or industry helping the government, I don't think it's that hard. If somebody really, like she was saying, if somebody really makes an effort, it can be done at the central government level. That is not an issue at all. We can be part of right from the DPR stage of the proposal. Especially IITs, are rated very high. So they quickly go to IITs. See, for me itself in Ladakh, though we are not from IIT, we are involved with all state agencies in these things. It's not that hard. We can make an entry. It's just that somebody has to have that kind of, for us, the governor of Ladakh we know, and the Kashmir also we know. So we are called for all those things in the state departments. As recently as in Karnataka also, they wanted to design something in this Kalaburgi and all, they called us for monitoring, for giving them an evaluation and all. Whether it is geotechnical, seismic, that is not hard. So that's my viewpoint.
Thank you. Very interesting. Akshay Jha has raised this question. Any points?
Point, sir. I would like to add only one thing about project execution and say site investigation and design part of it, sir.
Yeah.
Basically, what happens typically on our projects, whether it is railway project, I don't know much about highway, but railway projects I am completely familiar, sir. We do not devote much time on investigation and design aspects. Whereas if you look at a railway project being executed elsewhere, like I have worked in Malaysia, sir, almost say about 40% time is dedicated for investigation and design, and then remaining 60% time you execute the project. Whereas in India, we are not able to focus on investigation and design. We simply jump to site and then we encounter problems and then we start finding a solution. Of course, mindset is changing now. We are focusing, we have started focusing on investigation and design, but the problem which was being discussed previously, the quality of investigation, the NABL accredited labs, ethics and all, those things also do come into picture. And one last sentence regarding, I think, interaction between academics and industry. We have enough opportunities for students from BTech and masters, even say PhD students can come and see a few things on railways. Also, we have large number of projects going on. Like say we have now stone column work is going on for ground improvement of railway embankment. I tried few local colleges. Of course, I did not reach IIT Hyderabad, but people are not coming forward even for site visits. So that probably we need to change our mindset. I mean, maybe when academics people can think of, motivating people for site visits, because that gives you a lot of insight into how work is done at site, apart from what we study in colleges. Thank you, sir.
Thank you, Akshay. Dola, do you have a point to make?
Yeah, I can actually add to what he just mentioned, and a similar point was made by Dr. Ramakrishna during his talk when he talked about accountable, self-introspection and making continuous education mandatory. So if we really are looking at the undergrad level or the PG level students also to come down to the field and see this kind of application happening at site, somewhere down the line, the internships have to become accountable internships. Because almost every college, I'm not even talking about the IITs and NITs, which probably have a much better infrastructure in place. But even the local level colleges, what he was just now talking about, that even if you ask them, they are not interested in coming down to the field because somewhere down the line there are no credits specifically attached to it. So at an undergrad level, the student more often looks at the number of credits that he has to log in. So unless this kind of internships are made accountable, there is going to be a resistance from the students also. And end of the day, a 19-year-old or a 20-year-old has a whole range of different interests than like what Dr. Dipankar said is, than to love geotechnology. It's like he has other things to love at that stage than actually trying to love geotechnology. So unless it is made accountable, it's not going to happen. And that is where probably...
Very nice. Yes,
Actually,
your point, it has to be made accountable. Somebody
right
else?
now, I think, I mean, just to add that, I mean, we are in, say, various board of studies, and we are actually promoting that, and most of these colleges, universities especially, they are making it mandatory. At least 3 credits are actually assigned for these kind of internships, but they have to make sure that students should go to a particular site and learn, or at least an industry, to learn something and come back. It should not become like, again, on paper and they
exactly.
just on paper.
It should not be a piece of paper that you generate from somebody at that industry. Because frankly speaking, it's sometimes sad when I get a call that, look, my such and such nephew's friend needs to do an internship. So can you please accommodate him and provide him a certificate?
Yes, understood. Shall we move ahead a little?
Amit
has a question.
Yeah, I have a point on that. So coming back to hill roads, etc., I see geotechnical is still an unorganized sector in a way. And why I say that, many of the very important codes are very old and they have not been updated, and they are wrong many times. And that has been in practice, including geotechnical investigations. Do we have really good code even today? I don't think so, right? It's a SPT test, how to do this test, how to do that kind of thing. But geotechnical investigation is much more than that, right? Now, another thing is, I think most of the time we end up developing these things from instrument point of view or generic point of view, but actually it should be sectoral. So a water resources department doesn't want to do slope stability for canal. Why not? Because their codes don't ask for that. They say 1:2, done, finished. Whatever soil is, doesn't matter, right? Now we have never, I'm sure that we must have done that, but to what extent, I don't know. So I think we need to seriously think about sectoral development of codes and guidelines, because that creates accountability. That is what we are talking about. And that should be developed in coherence or in collaboration of industry and academia, along with the owners, the government sector. That should be party to it in a way. That is a brief comment.
Yeah, thank you, Amit.
Professor Muthu,
you have something?
Yeah, thank you. Actually, I'll just talk about the III Institute Industry Interaction. We do have a good model we have introduced in our curriculum. And after all, after doing their degree, of course, they are seeking the job. So rather, we have planned a system called a win-win situation. So from day one onwards, we are trying to tie up with the industry, and we do have a course called Geotechnical Practice. We introduced in our master's curriculum. So that course will be fully handled by industry expert. And thereby our students will start from the day one self industry interaction. And I'm very happy to say that probably Dr. K. Sir very well known that our people consecutively, 2 years consecutively received the DFI Best Paper Award because of the very, very keen industry interaction. So this course is fully offered by the industry person. Of course, Dr. Kumar Pichumani is partly handling the subject for us and helping us. And we do have a project MOVE. We are trying to tie up with the industry. The project, joint project, master's level project. We are having a tie-up, and somehow this model is helping the students to get the placement as well as internship. So we are trying that model. Our geotechnical practice is very well reaching to the students with the industrial input. So probably Professor Raju also mentioned, made an appeal that we need to think towards having some sort of evaluation component in this industrial aspect. So probably in our curriculum, we can try to have some sort of model related with the industry interaction. Thank you.
So I had a small point in continuation with Professor Amit. Yes, there are a lot of agencies, IRC, RDSO, MOR, or BAS, so for updation of the codes. But we have to make some consistency actually with the current state of the art techniques, especially if I say on the landslide safety or the hill slope safety. These actually agencies, because Madhurima is also here, I guess. So these agencies have a number of internal memos for regulation of construction practice. So I think the review of that should also be undertaken, I guess. So if that can happen, then there may be more clear points to be taken at the field scale. Thank you.
Thank you, Nilima. Shall we move to next question? Sirish?
Yeah, please go ahead. Yeah. I mean, is there any consensus or like points to be raised on this point? Otherwise, we can move ahead.
I think we've got sufficient views from everybody on this.
Sure. Please go ahead.
Yeah. Another question that the industry is facing is this. There are a lot of bridges coming across the large rivers, Ganga, Brahmaputra, Yamuna. And we are still looking at this cover depth calculations by Lacey's formula. And this has been a big question, 2 times DSM and all this, 2 times DM, sorry, to be taken, whether it is correct, whether it is not. This, nobody has worked on this. So I would rather like, because I am facing the same problem, I would rather like the academia to look into this, how it could be sorted out, or if there is something, it should be put in the IS code or IRC. We still are using the old silt factor has been changed more marginally, but I think the lot of this thing is required in this, because this affects liquefaction directly. So liquefaction, we had a lecture, so that was quite interesting, and we used to follow the IITK guidelines. Now if IRC is coming up with straight guidelines, then that will be good. I know it has come. We have started using, but that will throw some light. Any points on this from the academia, please?
Maybe Professor Amit, you were talking about liquefaction and Yeah,
I
so, yeah, maybe I mean just you, then we can take it forward. Yeah.
I mean, about the silt factor, etc. I think I have faced this problem in many projects. I can say it's a big issue that you just do one weird number and just assume that it will work, kind of thing. And somehow it has worked most of the time because it is too conservative for anything to kind of fail in that category. So I think the collaboration between hydraulic and geotech, this is a good example of that in a way. And as an engineer, owner's engineer, you don't care actually whether it is geotech or whether it is water resource or whatever, right? So I think as an academic, we have done a lot of research in this area. There is enough knowledge available, but that has not translated into codes. And that is where the challenge is, I would say. So whether it is BIS or we talk about IRC, I think everywhere the same issue is there. About 1893 that we had for earthquake engineering code, GSDMA guidelines was basis for that in a way, for earthquake liquefaction issues. That is a generic guideline. But what with IRC we have done now is a very specific bridge foundation design kind of thing. So how to do the analysis, what factors to consider, what loading to consider for earthquake, what load cases to consider, and so on. So this will be like a very good design guideline in a way, end to end, something like that. But definitely it still not addresses the silt factor issue.
Right. Thank you, Amit. Yeah. Any other viewpoints from any of the colleagues? Basically, there is a comprehensive study or committee which is like to be addressing. Addressing all the aspects. And that's one thing we need to look into, or at least suggest IRC or IS code system. Like, yeah.
Well, Border Roads Organization has published a document which addresses the silt factor and the scour depth computation for the boulder gravel deposits, because the Gnss theory is applicable to alluvium soils. But many Himalayan rivers, they carry a lot of boulders also. So Border Roads Organization has published a document. I have that document with me. I can share that with Professor Muthukumaran, and he can
circulate it.
Yeah, surely I would like to share that.
Excellent.
Thank you, Professor.
Thank you.
Very nice. IIRC has also included a section on bouldery strata, I think. So maybe you can have a look whether these two match, or somebody has to compare and see whether there is agreement between the border roads and what is there in the IRC. Okay, if there is no other viewpoint, shall I move to the next question?
Yeah, please.
Yeah, another major issue which bothers all of us is rock. So what is rock? Definition of rock. All the codes talk about highly weathered rock, marginally weathered rock, totally weathered rock, but there is no definition, and each definition is different. Now, in typical rock mechanics or more towards geology, we have something called RMR. So it is a magic number. Whatever it is, let it be a magic number. At least when you know that the RMR is 50, you know what support has to be provided, and over the years it has worked and it will work. And then you can use some modeling technique to check whether you need to increase the bolt length by 1 meter or 2 meters or some other method. But at least you have a ballpark figure. Now here in the civil engineering industry, when you have to socket piles in rock, we have got a lot of research done in socketing of piles, and everybody suggests 2D, 3D, 4D, 5D. Now question is whether the industry will be able to do it. Which equipment should I use? All the equipment manufacturers base it on only the UCS. And all the faculty will agree that it is not only the UCS that matters. There are so many other factors that matter in deciding which equipment to use or what type of a cutter should be used. There is a huge gap between the academia and the practice over here. I would request the academia to please look into this aspect. I know it is a big research, it is a basic research. We are ready from the industry to give you all data. You can put your students at site, see the torque, see the RPM, see whatever you want. Take the samples out, what RQD, what core recovery, all the parameters, fuzzy logic, whatever you want, you can use. But please, somebody come and do this research. Because the ultimate point is the contractor says, no, boss, I cannot move my rig. I'm stuck at just 1D. I cannot go for 2D or 3D. Main problem, maybe the equipment is wrong, but how do you prove? How do you say that it is correct or how it is wrong? If you say that, no, you have to go, then there is a claim. So right from the day one, there is claim. This is one biggest aspect. Can somebody throw light
Can
on
I
this?
make a comment, Pishmani?
Sure.
Can I interrupt? I need to leave. I have another meeting. Okay.
Okay, please.
Sure.
Yeah, please. You can.
Thank you so much.
I just wanted to say,
yeah,
give you a Bangalore example. Hard rock, you cannot go more than 30 centimeters. You may write whatever you want. 1.2 meter diameter piles, 30 centimeters. And then the design load is some 680 tons, absurdly low. And when you test it 2.5 times the design load, it will settle 3 millimeters. and if your requirement is 2 meters, the contractor will say he has gone for 2 meters and stops at 30 centimeters. So this is very unrealistic. So this is, one has to be really very thorough on this. That's all I wanted to say.
Thank you, Professor Raju. But the main question is, what equipment does he use?
Oh, no, any equipment you use, you can naturally core it. See, I was talking to people in Singapore, and they have heavy rotary equipment where they cut through. Those equipments are not available in India, and it's very expensive. In Singapore, they will say, we are a very rich country, we have no problem, we'll pay for you. And here, people don't pay, no. So therefore, the contractor cannot do that. It's not really necessary. Why on land when you're only having pile foundations, and then what is the need for taking the pile 2D into hard rock? It makes no sense.
The main question is, we don't find hard rock always. So
No,
it's
no,
basically
that
the
is
weathered
clear.
rock.
That is clear. You have to do a thorough investigation, perfect coring. If required, double core barrel or whatever it is, then clearly identify
hard rock is not an issue.
what is weathered rock, what is hard rock.
Yeah, the question is the weathered rock.
Yeah.
Where the
Weathered rock,
contractor
naturally, you have to go deeper, 3D, 5D, like that, depending on the degree of weathering. See, anyway, finally, the thing has to be proved by actual load test. So you do an initial load test and accordingly decide how deep you are. I will send you my presentation on this Bangalore project. Bangalore Elevated Expressway. I have a presentation where we had hard rock, we have weathered rock, and different categories of rocks. And depending on the degree of weathering, we decided for different depths. And there's some 18-20 pile load tests have been done. And I'll share it with all of you. No issue at all.
Thank you. Any other viewpoints?
Yeah, may I?
Yeah, most important thing is the client is ready to pay. Most of the time, as someone has mentioned, you are going on L1 basis, and most of the time you are forcing.
Your internet is weak.
Your voice is breaking.
So most of the contractors do.
We can't hear you, okay, sir.
Dr. Kesar, probably you can take out a video.
No, we can't hear you, Professor Kesar. Yeah, somebody else had a point, I think.
Yeah, I think Dr. Parth.
Yeah, I'll just quickly. See, Bangalore has essentially 3 stratigraphies now. You have a overburden and a sheet rock, which is very massive, but you have an in-between layer between the overburden and sheet rock. It is a refusal stratum. SPT will jump, but if you try to use the conventional calyx type rotary machines, which will not rotate at an axis, it will wobble, you will definitely not be able to capture any core samples. And throughout the depth, the thickness of this refusal can vary between somewhere maybe a couple of meters to as deep as around 20 meters. So this is just not the problem with pile socketing, but also we see regular problem with the excavation. The deep excavations going to about 15 meters, 20 meters these days, you have a puckline which can excavate through the soil, but the other methods like diamond cutting to excavate massive rock, you don't have any methods for these intermediate soils. So how to quantify this is only by adopting some triple tube core barrel where you don't have the access of the drill fluid directly to the core samples and recover core samples and test it for its compressive strength. You can measure the unconfined compressive strength between somewhere around 2 MPa to around 10 to 12 MPa. So the massive rocks can be around between more than 30 to 120 MPa is not uncommon in Bangalore. Therefore, you need to decide what kind of equipment has to be used in the geotechnical investigation. In fact, the entire information I brought out in one of the books that is getting released, the Geotechnical Soils and Rock, spearheaded by Dr. Shukla on the soils of Karnataka. So one part of these Bangalore soils have elucidated. It is likely to be released by end of this month. So I can share more information later on based on our experience. We have serious challenge. I now privy to a couple of arbitration, whether what is right, what is not right. The contractor has a poclane which cannot excavate refusal stratum. It's not a bedrock either. The contract fellow come and show the sample is not bedrock, but this man is not able to excavate. So the project is on hold. They are on arbitration. They are fighting. So who is to be blamed? The owners not employing a good geotechnical investigation, or the contractor who has done what is not supposed to do. So it's a big debate. So we as profession has to come together and then solve this problem, what is appropriate for that particular type of soils. Thank you, sir.
Thank you, Dr. Pastarthi. I think we can move ahead with the next question. Sirish, can you take it up?
Yeah, actually, Dr. Pichmani, we have some questions from the audience, delegates.
Am I audible?
Dr. Ramakrishna, you are audible. Probably you can turn off your video.
Sorry, I had a very bad internet connection right now. I think
even now it is bad.
Of our long session.
No,
is it okay? Okay.
No,
Sorry,
it is not. Can't hear you.
Okay, then I think I'll skip.
Yeah, probably at the end you're okay. Your voice is okay. Maybe turn off your video and then maybe speak.
Yeah. Is it okay now?
Yeah. Please go ahead.
Okay, I think because I just wanted to say that it is when it rock and when it is rock, it is definitely a discussion and a debate and a quarrel. And what needs to be done is, as Professor Raju is telling, the realistic approach to the socketing length. Tomlinson had brought out different curves of what happens if you go on increasing the socket length. It is useless because beyond certain maybe 1.5 to 2, the load doesn't get transferred to the end. So it is all in the skin friction. So that curve, if you look at it and reverse it, you can get a very clear understanding of rock socket. But most of the time, the client insists on going deeper and deeper. But
we can't hear you. Again, your voice is
method
gone.
of you cannot ask 100. Okay.
Yeah, probably we lost him. I think bandwidth issue.
Sorry. I think I'll skip.
Yeah. So we could understand that you're talking about like why to go for embedment depth of that much, like 2D, 3D, and all. So somebody can look into definitely, because embedding is not a matter when it is like a socket into the rock, and we don't need to definitely go for that deep. So yeah, that is his point. Probably we are okay with that. So there are some 2 questions from the delegates. Let me read it for the committee. Panel here. So what steps could the geotechnical engineer take to bring out their involvement and importance in projects, seminars, conferences like these are attended by geotechnical engineers, which is needed. But we should also look into encouraging civil engineers like other groups like structural engineers and hydraulic engineers to be here. So that's because we have been talking about involvement of water resources persons, and while talking about slope stability in canals and so on. So is it a good practice or something like that? So that's the question about. Yeah. Professor Sitaram.
Yeah. Can I come in? Yeah, you see, I think, I don't know who has asked this question. Is a student?
Not really sure.
No, the name will not be known.
Name is not known here. So.
Unfortunately, he has not, name has not mentioned.
Let me answer to you. See, my suggestion is, are we too much specializing? Today, civil engineering, I think, geotechnical engineering doesn't speak to structural engineers, structural engineer doesn't speak to water resources. Yeah, is it really too much of specialization? Unless we need to, because we need to know many of the other discipline areas to solve a problem in foundations or slope stability. All these actually, it's very becoming a multidisciplinary within civil engineering only. Forget about coming from the external world. I mean, other areas like electrical, computer science, living that itself within civil engineering itself, we are now too much of compartmentalized. I think the boy, whoever has asked the question, is very relevantly asking a question. Should we really too much of specialization? Are we not ready to talk to others in our own departments? And I think this is a very serious question. I think we need to address this. And because I think only in our country, we do have this MTech in Geotech, MTech in water resources. Everywhere else is MTech or MS in civil engineering. Okay. Sure. See, this is, I don't know, I think we need to change somewhere. Otherwise, I think too much specialization, nobody speaks to the others. And here also, as he rightly said, we are mostly geotechnical engineering. And we are actually going in the direction of structural engineering. We want for everything a code. I don't seem to understand. You are dealing with a material which is so complex. Codes, very good development. I'm not against development of codes, but you may not find codes for everything in geotechnical engineering because it's an art. Please, you have to remember, geotechnical engineering practice is an art. And recording whatever your experience in a form of a guideline, it is very welcome move. But I think we shouldn't be looking at for everything a guideline or a code. Somebody has to prescribe for you. This is what you have to do. I mean, I think it depends on the site, and someone should study properly the geotechnical report. As Professor Raju was highlighting, first you should do geotechnical testing properly, and then analyze that properly, and then go for that. Thank you.
Sirish, can I say something?
Please, sir, please.
I want to take advantage of Professor Sitaram's presence here. No, you have definitely in a position to change certain things. For industry institute interaction, I think in the IT system, or in the academic system, the method of evaluating people for higher positions should change. What I recommend is that give also weightage for working for, let's say, nation like code preparation, participating in preparation of codes. Because why nobody wants to participate from academic is it's not recognized, it's extra work for you. And similarly, working with the industry, give a proper weightage. Some people are inclined to spend more time in research and some are more inclined to do field work. So if we change your method of evaluation for promotions, that will definitely make a huge difference among the package. The second thing is make it compulsory for the students to do internships, even in the IT system, both at bachelor's level and master's level, even at PhD level. If somebody is doing a PhD in geotechnical engineering, ask him to go and dirty his hands somewhere at a site and in the sun, either observe how the geotechnical investigations are done or how a dam is built or deep excavations are done. So some of these people, I'm sorry to say this, some of our even younger faculty, they have no idea at all. They have hardly been out. They have only done some Plaxis analysis, finite element analysis, one more finite element analysis, and one more finite element analysis to get a PhD. How does it make somebody a geotechnical engineer? So I want to stop here. So Sitaram, we look forward to you to take some initiative in this.
Absolutely true, Professor Raju. I agree with you.
Thank you.
Whatever you said, there has to be a better interaction.
Can I?
Sitaram.
Thank you so much. Thank you. See, we, the last 2 years at IIT Guwahati, we have created a new group called Industry Interaction Special Initiative Group, which is actually led by a dean. And it is not just civil engineering or just geotechnical engineering, everywhere. And every department, I have put 3 industry advisors. I think Professor Parsarthi, Dr. Parsarthi will agree. He has just accepted also to be on the civil engineering side. But it is not just for civil engineering. What I have done is there will be 3 to 5, or depending on the areas, 5 to 6 people will be the advisors to the department. Department will have a regular meeting and to see what are the needs of the industry, so that luckily, IITs have a very large freedom to change the curriculum. So this curriculum will be directed by the industry experts along with our faculty. So this is what is happening now. And also, as Professor Raju said, internships. So we have made it compulsory now for all BTech. Even we are allowing internship for PhD students also, because if they want to take a break, because they're all supported by MHRD fellowship, that came into a bottleneck for us, but still we allowed. If they want to choose an internship where they go to an industry, work with them and come back, that is also we have allowed, irrespective of the field. I'm not talking about only geotechnical or civil engineering. It is the entire IIT Guwahati, we have done this. It is really sent a very fantastic signal, because in the 2 years pandemic period, more than 22 or 24 technologies have been transferred to the industry. More than 22 companies are actually placed in our research park at IIT Guwahati, which is very similar to IIT Madras experience. See, IIT Madras can claim because it is in a major city like Chennai, Delhi, Bombay, they should not have any problem. I'm talking about Guwahati. There was nothing there when I joined here. Today, I can very confidently say 22 companies have placed their thing in our research park. Even our research park building is not completely ready. By January, it will only get ready. But we have put them into our R&D building, and they are very quite happy with the kind of technologies transferred. More than 35, 40 technologies were given during the pandemic period related to COVID and other, biotech areas. And I think there is a hope actually. But coming to your evaluation, sir, you do agree with me, and it is only a problem of civil engineering.
Yeah, that's true.
So automatically we try to do something there. And I have seen even some of those geotechnical consulting type, they don't really get involved. See, please understand, they do geotechnical consultancy without getting involved. So I think that is simply, because there are no people. So they do take some opinion, but you have to go to a site visit, understand the problem. Many of them don't go to site visit, start writing the geotechnical testing report, sitting in their office, which is, I think, unacceptable. I think some ethical, practices have to be done, and people have to be quite serious about how to get involved with industry. But one thing I can confidently tell, that India has brought on to large projects, and what has not been done earlier, they are doing it. Industry is doing it. It's a fantastic opportunity for the academicians to get involved with the industry, to learn many, many things, because the kind of projects, whether it is in Kolkata, below the Hooghly River, the underwater tunnel has been done, twin tunnel. And similarly, large structures are coming up, and in a very soft soil, a lot of work is happening, whether it is petroleum, energy, anything what Indian industry is doing is very big, and it has never been done anywhere in the world. See, even in Chenab Bridge, where only one experience I have, maybe about 10 everything is a world record. Okay, whatever they have done, whether it is a crane, building a crane, or launching this bridge itself, methodology, everything is a first time. So I think there is a lot of learnings to happen. So I urge and I ask students to visit such projects. And thanks to Government of India, they are also allowing now. They are inviting colleges and students to send to those projects just to get an experience. So I think some of these opportunities also should be used and made aware of the realities, what goes on in a geotechnical site, and that should be brought into everybody's experience. That would take us a long way as a geotechnical practicing engineer. Thank you.
I agree with you 200%, Sitaram, what you said, and I also want to congratulate you. And I think you should disseminate this information also to other institutions. But only one suggestion I have, it's a revolutionary suggestion. I don't think our faculty in the IITs like it when I say this. You must ask the government to remove the requirement that get it approved from one of the IITs. This is such an absurd thing. No, what their industry is doing, no, I know that because as a geotechnical consultant, very active, I know that. They will tell you it's so easy, sir, to get an approval from an IIT. I go in the morning and sit in front of the table and then I get a stamp and approve.
So that is what I said, sir. That is
I
why
mean, you see, this is so dangerous. One day it will boomerang on the IIT system. So I think whether people like it or not, I think we should speak out. And then I'm sure there are many good people who do a thorough job. They go out to site and all that. I'm not belittling any of the IIT faculty, definitely not. Because I was one who was promoting all this. Just like you were saying, I was also Dean ICSR, Industrial Consultant Sponsored Research at Madras. So I know what it means. But this type of thing should go. So I had it from many professors from IIT, exactly what you said, no people writing reports, sitting in the office and they're approving it across the table. This is absolutely absurd. This will ruin the institution, in my opinion. Thank you. Sorry if I have spoken too much.
Thank you, sir.
Thank you, sir.
Thank you, Professor Raju.
Professor Samadia has a point. Yeah. Professor Samadia has a point.
Professor Raju, I 100% agree with you and request Professor T.G. Sitaram also. Because for the promotion, like for the first selection, what do? We go for the publications in international journal. And what type of publication it is, whether it has got the something which is related to field, we don't see that. We only go for the publication. And for this promotion also, even we consider that the teaching the faculty will be doing. So we don't give any weightage to the teaching. That has to be done. You are supposed to teach it, right? And now the things are that how many projects you have got and what is the amount. Like if it is less than 60 lakhs in last so many years, you will not be allowed to even appear in the interview. So those are the things. And especially, I don't want to offend my academicians colleague. Now you will find, sir, some of us teachers, they can't differentiate between silt and fine sand.
Yeah, true.
And for them, soil is only a spring. I'm not against any numerical modeling and all those things, but that is the situation. And in industry also, like we have so many laboratories without skilled technicians, without knowing anything, they are giving all the reports. And nowadays, in most of the cases, most of the reports are vetted by higher institutes like NITs and IITs. And we ourselves are not very honest. Whatever report comes to us, and we vet it as per the requirement of the agency. So that is also one of the reasons, sir.
Actually, you have a key role, Professor Samadhya, as president of IGS. I think you can really bring it out. I think I will speak out because I have gray hair, so I can speak whatever I wanted to say. If I'm wrong, let people say I'm wrong. I don't mind that.
No, sir. You're absolutely right. I have discussed it with so many directors also.
Yes.
Like for the promotions, especially for the teaching. They say, yes, everybody has to teach. That is part and parcel. That is understood.
Yeah.
Very good, Samadhya. Very interesting.
Thank you, sir. I think Mr. Sudharam has a point.
Sirish, I'll just make one point to
Sure.
Samadhya, since he is the head of IGS. This question that we raised now, that each one is different, like hydraulic engineer being different, and these, we should invite them also to IGC. Next IGC, we should invite all the other engineers. It should be open for all. What is your suggestion on that?
I think it is always open for all.
Pichumani, first you should merge all these disciplines into one MTech.
Correct.
With the specialization. You see, MTech in civil engineering with a specialization in hydraulics, MTech in civil engineering with a specialization in geotechnical, that is allowed. But you cannot have a MTech in geotechnical engineering. What you will do alone?
Correct. Exactly.
No, we can have a master's program where one major and one minor.
Correct.
No, like that.
Yes.
Geotechnical major and then hydraulics minor or structures minor.
Exactly. Because as Professor Samadia pointed out, the soil is considered as only as a spring by the structural engineer. For them, it doesn't matter.
No, but even by soil engineers, it's considered only as a spring.
No, that is
by structural engineers.
Yeah.
It is the same way, please understand, it is nothing different between soil, water. Those people also, they think that what they are doing is the multidisciplinary thing. So we need to talk to each other because it's all coexist. They all coexist together. See.
Correct. They all work together. The entire system works together.
No, material exists together. We are not together.
Yeah. Nature is always together.
No, but actually, I want to share my own experience. At IIT Madras, when we were doing, we had in our team geotechnical people, structural people, hydraulics people. Any project, all the three were involved. So everybody looking at a different aspect and coordinating. Even in those days, I'm talking about 90s. So we were doing this.
Sir, you are in ocean engineering department where you brought all these people, different expertise.
Now, what I'm trying to say is, it is possible. There are people who are doing it. Now you are taking it forward.
Correct.
And I think this is the debate we should have, really. And then, IGS can really create a forum for debate only on these issues, procedural issues.
Yes, exactly. That's true.
So that's what we do at IIT Roorkee, especially for the consultancy projects. We form a group in which most of the disciplines which are required. So we work together. So that's what we do. We are not like we consult the hydraulics people, we consult the structural engineering people, transportation engineering, wherever it is required. So normally in a team we work here. At IIT Roorkee, at least I know.
Yeah, sure.
I may add to what Professor Samadia said and some others have also said, at the risk of inviting the wrath of some of the academia, I would like to say that, whenever a person is appointed as a lecturer or a professor in a educational institution, he should have at least 4 or 5 years of experience in the industry before he becomes a teacher, so that he is able to teach the right things to the students.
That is the German model. That is the standard German model.
To add to it, actually, I have a small point. I mean, instead of if you don't find such people, then what we can do is we can also allow faculty members to go to the industry, maybe a sabbatical for 6 months. Why not we do that? And allow them to work there and come back and then again resume their thing. I mean, again, I think Dr. Pichumani has done that and he never come back. That's the only difference. But something can also be done.
This should be done before the person gets his first promotion.
Yeah, it should be considered.
Yes, it should be related to the promotion. There has to be some monetary benefit or appreciation benefit in this.
No, when I say sabbatical, it's all paid leave. So they'll be coming back with
leave. It should be recognized.
Sure.
As a contribution to his success.
Sure. Any other points? I think we have deliberated a lot on this particular aspect.
There is one point.
Sure.
Given by Professor Amit.
I'm just reading it.
Please take up that.
Right. Amit, yourself can speak.
Yeah. So I think I had discussions with many people in practice, especially. And this business of vetting, as if IITs are sitting as a licensing agency kind of thing, right? This is not a good practice. And it is never respected by any practitioner. I have not met yet who respects this kind of practice that is happening in IIT system. And probably it's in NIT system also. So I think we have to think about it, which is something which should be stopped or contained to a certain extent. Helping each
Very
other
true.
is very good. I'm not questioning that at all. Working together, no question about it. But this licensing business key, I'm going to stamp it to say whether it is okay or not. This is not correct. And professors are not engineers by profession. They are professors, they are teachers.
No, but Amit, there is also a very important aspect. According to me, if you have to proof check, you have to spend 50% of the time what the people have spent on design. That is proof checking. I mean, you know, in fact, it may be more than 50%.
Yes, sir. In fact, it may be more than that.
Sometimes it is more than that, sir.
Yeah. So
But
therefore,
in
we
order
don't, you
to-
don't have so
the
much
detailed
time.
design.
You don't have so much time.
In order to find the mistake, it takes longer time than you can design yourself.
Correct. It is actually a detailed design, a separate design altogether.
Yeah.
That is what we call as an independent consultant in industry, who
Right.
does his own design and then checks the drawings of the detailed designer.
Probably.
So therefore, the way
Amit-
out is that we have to give at conceptual level and do away with the routine type of calculations. You know? It is just the input parameters, right? That's it. Then you have to assess the situation clearly and guide people so that they can do all the calculation. In fact, the youngsters do much better than us. Even you know, first year BTech may do better computer analysis than professors can, because they are more up to date than us. So I think it is, we are going in that direction. Only thing is how fast we can go there. That
I want to give you some statistics on this. You see, we have looked at the numbers. See, our consultancy of IITs are very insignificant. I think what we talk about is we talk about too large, nothing. Actually, our research turnovers are 250 crores, like that. But our consultancy money is less than 10 crores per year.
No, but IIT Madras is 100 crores.
IIT Madras is special, sir, something. And everything, IIT Madras is really special because I think they have done a tremendous job, good job also. Let me appreciate their work. You know, they have done, whether it is industry interaction or creation of the co-locating industries, in everything, you know, they've done a fantastic job as a model. And I think we need to emulate, but at the same time, I wanted to give the real statistics across other IITs.
I agree.
Other IITs, consultancy amount is too small, and also very few people are getting involved, because not many. And I completely agree with you. This business of vetting has to go. I mean, I don't know whether they will simply waste their time as well, and also the institute time.
Now, I think in fact, I did write to some of the directors that they should look into this aspect. You know, see, for example, in IIT Madras, it happened that when something went wrong and they blamed the consultant and they called even the IIT director to appear before the court, something like that. Because who is responsible? The government or the agency is thinking that it is given by the IIT, but it's not given by the IIT. It is given by an individual of the IIT. So
IIT Roorkee, two professors were arrested.
Yes, absolutely. So that is the issue.
Okay.
Very good. I think we can go to other issues. We have discussed a lot, and I think
thank you very much.
Sitaram, I look forward for a small note from your office on what you are doing. I'll be very delighted.
Sure.
Yeah, sure.
Right. We take this opportunity. Thank you very much for being with us. I think we should have a small snapshot if everyone puts on their camera. So
yeah, please switch on.
we couldn't do that. Amit, I can see you. I cannot do that. Just kidding.
That's why I did that.
Right.
Dipankar has to switch on.
Yeah. And Ravi Kiran? Murali? Wow.
He's at
the side. He's at the side.
Yeah. Professor Murali? Dr. Nilima?
Yeah.
Actually, I was doing this one from my other office, so I don't know, camera is not working.
Okay. Murali?
I think he's also having some network problem.
See, Ravi Kiran is the one who is at site now.
Yeah, now it.
It's a real photograph for interaction
Yes,
of industry and
yes.
academia.
Yes.
So yeah, please look at the camera. 1, 2, 3. Yeah, I've taken. Let me copy it.
Ravi, twist the camera a little bit. Ravi Kiran. It's bright.
No, you've
in the
already
back.
taken, I think.
Now it's better.
Yeah, I'll take one more. 1,
Ravi Kiran, smile, please.
1, 2, 3. Thank you.
Right.
Great,
Thank you.
great. Thank you very
Thank
much.
you. Bye-bye. Thank you. And also
Thank you.
thank you to the organizers. You have done a great job. Thanks.
Thank you.
Thank you, everyone.
Thank you.
Thank
Thank
you
you
all.
all.
Thank you.
Thank you.
God bless
Bye-bye.
all. Thank you all. Goodbye.
Thank you, sir.
Bye-bye.
Thank you very
Thank
much.
you all. Goodbye.
Thank you. We'll meet all tomorrow morning.
Mr. Kumaran, happy,
Yes, yes.
happy
Yeah,
conferencing.
see you
Yeah.
tomorrow morning.
Yeah, morning 9
Yes,
o'clock.
yes.
We'll meet in the inaugural.
Big day tomorrow.
Yes, yes.
Right.
Right. Bye-bye.
And
Thank you.
yeah,
Thank you.
all